Hi, thank you for taking my C# Basics course. Let me quickly give you an overview of what you're going to learn and how I've structured this course. In the first section, I'm going to talk about fundamentals of C# and .NET. One of the questions that a lot of beginners ask is, what is the difference between C# and .NET? So I'm going to cover that. I'm also going to talk about CLR, assemblies, namespaces, IL code, and stuff like that. Then over the next two sections, I'm going to talk about types. I'm going to talk about primitive and non-primitive types. Now at this point, you still cannot write any C# programs, but I have designed a number of quizzes to help you reinforce what you're going to learn. Then from section 4, where I talk about control flow, you're going to start writing simple C# programs. And from that section onwards, in every section, you're going to learn something new about C# and you're going to write more interesting programs. And finally, I'm going to conclude this course with a section on debugging. So I'm going to show you some of the tools we have. So when you have bugs in your code, you know how to find them and get rid of them. I'm also going to talk about some good programming practices that help you write better and more reliable code. So we have a lot to cover, and let's get started. Hi, my name is Mosh Hamedani, and in case you haven't seen my other courses, here's a brief introduction about me and my story. I started programming at the age of 7 with a Commodore 64, and I totally fell in love with it. My dream back then was to become a software engineer and build a 3D tennis game for myself to play. So that dream affected the rest of my life. I continued education at the university and studied Bachelor of Science in Software Engineering and Master of Science in Network Systems. Now, the reality is I never became a game developer. In fact, I know nothing about games. In late 90s, web was a big thing. A lot of companies needed a website. So I started working professionally from year 2000, and at this point in year 2015, I have 15 years of professional experience in the industry. Now, in case you're wondering what my life is outside programming, I love to play a bit of jazz piano, I love cooking, and I love Latin dancing. I've been dancing for a few years, and I love bachata, salsa, and cha-cha. So if you're watching this from South America or Spain, hola, ¿cómo estás? That's pretty much all Spanish I know. If you want to find me on social media, I have a blog under programwithmosh.com. I also have a Facebook page and a YouTube channel by the same name. You can find me on Twitter under Mosh Hamedani, and my email is programwithmosh@gmail.com. I hope you enjoyed this course, and I will see you in the next lecture. Okay, so this is the very first section of this course. In this section, I'm going to start by teaching you the very basics of C#. One of the questions that a lot of beginners ask is, what is the difference between C# and .NET? So that's the first thing I'm going to answer here. Next, I'm going to talk about CLR, or Common Language Runtime, which is the runtime environment for .NET applications. Next, I'm going to talk about the architecture of .NET applications. And as part of this, I'm going to introduce you to concepts such as classes, namespaces, and assemblies. And finally, I will show you all these concepts in action. I'm going to introduce you to the very basics of Visual Studio and write a very simple C# application so you can see classes, namespaces, and methods in action. I hope you enjoyed this section, and let's get started. Okay, what is .NET Framework and how is it different from C#? Some developers who are absolutely new to C# don't know the difference, so in this lecture I'm going to talk a little bit about C# and .NET Framework. C# is a programming language. .NET is a framework for building applications on the Windows. .NET Framework is not limited to C#. There are different languages that can target .NET Framework and build applications using that framework. Examples are F# or VB.NET. Okay, now, but what exactly is .NET Framework? .NET Framework consists of two components. One is called CLR, or Common Language Runtime, and the other is a class library for building applications. In the next lecture, we'll talk about CLR in more detail. Okay, before we understand what CLR is and why we need it, let me explain a little bit about the history of C#. Before C#, we had two languages in the C family, the C language and C++. With either of these languages, when we compiled our application, the compiler translated our code into the native code for the machine on which it was running. Which means if I wrote an application in C++ on a Windows machine with x86 processor architecture, the compiler would translate my code into the native code for that machine. That is a Windows machine with an x86 processor. Now we know we have different hardwares and we have different operating systems. So if I took that application, that compiled application on a computer with a different architecture, that would not run. So when Microsoft was designing the C# language and the .NET framework, they came up with an idea that they borrowed from the Java community. In Java, when you compile your code, it's not translated directly into the machine code. It's translated into an intermediate language called bytecode. And we have the exact same concept in C#. So when you compile your C# code, the result is what we call IL or intermediate language code. It's independent of the computer on which it's running. Now, we need something that would translate that IL code into the native code for the machine that is running the application. And that is the job of CLR or Common Language Runtime. So CLR is essentially an application that is sitting in the memory whose job is to translate the IL code into the machine code. And this process is called just-in-time compilation or JIT. So with this architecture, you can write an application in C# and you don't have to worry about compiling that into the native code for different machines. As long as a machine has CLR, that can run your application. Okay, now let's learn about the architecture of .NET applications. At a very high level, when you build an application with C#, your application consists of building blocks called classes. These classes collaborate with each other at runtime, and as a result, the application provides some functionality. Now, what is a class? A class is a container that has some data, which is also called attributes, and functions, which is also called methods. Functions or methods have behavior. They execute code. They do things for us. Data represents the state of the application. Let me use an example. Think of a car. A car has some attributes, like its make, its model, its color. These are the attributes of a car. A car also has some functions. We can start it, or we can move it. So you can think of a car as a class. In a real-world application, we have tens, hundreds, or even thousands of classes, each class responsible for a piece of functionality. An example of that is classes that are responsible for getting the data from the user, process the data, and display something to the user. Now, as the number of classes in an application grows, we need a way to organize these classes. That's where we use a namespace. So a namespace is a container for related classes. For example, in .NET Framework, we have namespaces, each containing tens of related classes. We have namespaces for working with data, like databases. We also have namespaces for working with graphics and images. We have namespaces for working with security. Now, in a real-world application, as these namespaces grow, we need a different way of partitioning an application. And that's where we use an assembly. An assembly is a container for related namespaces. Physically, it's a file on the disk, which can either be an executable or a DLL, which stands for Dynamically Linked Library. So when you compile an application, the compiler builds one or more assemblies depending on how you partition your code. In the next lecture, we're going to write a very simple C# application, and you're going to see all these concepts in action. Okay, in this video, we're going to have a quick tour of Visual Studio and build a very simple C# application. So here I've got Visual Studio open. Let's go to File, New, Project. Okay, in this dialog, on the left side, we've got a section called Templates, and here you see the kind of applications we can build with C#. So as you see in the list, we can build desktop applications, web applications, apps for cloud, mobile, services, workflows, and various kind of things. But in this course and the subsequent parts of this course, we're just going to focus on console applications. A console application is a very simple application that does not have a graphical user interface. And it's a great learning tool for learning a new language. So we are not going to be distracted by various complexities of larger applications. So on the left side, select Windows, and on the right side, select Console Application. Then give a name to your project. So let's call it Hello World, which is a common tradition when learning a new language. And specify a location. You can put it wherever you want. And know this concept of solution. In Visual Studio, we have this concept of solution, which can have one or more projects. With a very simple application, you have only one solution and one project. But as your application grows, you add more projects, each responsible for something different. For now, we don't have to worry about it. Now click OK. All right, let's see what's happening here. Some developers get a little bit intimidated the first time they open Visual Studio. And that's fair enough because there's so many menus and panels here that is a bit confusing. But let me tell you something. 90% of the time, you're going to use only 10% of these or even less. So don't worry about all these menus here. You don't need to use all of them at all times. 90% of the time, all you need is the code editor here. And sometimes you need the Solution Explorer. In fact, I personally hardly ever use Solution Explorer because I do everything with my keyboard. And if you watch my course, Double Your Coding Speed, you will see that everything is possible with keyboard. So you don't need these panels here. You don't need to grab your mouse and navigate around. You don't really need this stuff. Also, none of the stuff on the toolbar are ever required. Don't worry about it. Everything you can do with your keyboard. All right, now let's take a look at this first C# program. So we created a console application, and on the right side, you see the Solution Explorer panel. In case you don't see that, go to View and select Solution Explorer. So at the top, you see we have a solution, which has only one project. Under that, we've got the project called Hello World. Look at these 4 items here. Properties, expand that. We have a file here called assembly info. This is the identification for the assembly that will be produced as a result of compiling this application. So when we compile a console application, we're going to get an executable, and that's an assembly. That assembly has an identification. Look at these attributes here, like the title, description, which is currently not set, company, product, copyright, trademark, culture, a GUID, various kind of things like even version. So these are all part of assembly identification or assembly manifest. In most cases, you don't have to worry about it. But if you want to create an assembly and you want to distribute it, send it to other people, then you may want to come here and give it a proper name and a proper version. So for now, we don't have to worry about it. Under references, you see any assemblies that this project is referencing to do its job. When you create a project with Visual Studio, by default, it adds a reference to a bunch of assemblies that you see here. These are all part of .NET Framework. So at a minimum, Visual Studio assumes you're going to use classes in system assembly or system.data to work with databases and so on. You may not necessarily use all these assemblies in your project, but that's just part of the template. App.config is an XML where we store the configuration for this application. Sometimes you may want to store connection strings to the database, or you may want to have some settings about your application. All of them will end up here. And finally, you see program.cs, which is where we're going to start writing code. All right, let's see what's happening here. So in this file, program.cs, on the top you see a bunch of using statements. What is this all about? Well, our project is called Hello World. So by default, Visual Studio creates a namespace called Hello World. When we write code in this namespace, we have access to any classes defined in this namespace. So if we want to use a class that is defined in a different namespace, we need to import it in our code file. And that's why we use the using statement.
So by default, Visual Studio has these 5 using statements. System is a namespace in .NET Framework, and that's where we have all these basic utility classes and primitive types there. System.collections.generic is used to work with lists, collections, and so on. System.link is used to work with data, and it's a comprehensive topic that I have covered in my C# Advanced course. System.text is used to work with text, encoding, and stuff like that. And finally, system.threading is used to build multi-threaded applications. In this video, we're going to create a very simple application, and we're not going to use any of these 4 namespaces here. So we're just going to use system. For now, I leave them there, and then I will show you how to clean them up. Alright, so here's our namespace. And inside namespace, by default, we have a class called program. So every console application you create with Visual Studio has a class called program. Inside program, by default, we have a method or a function called main. And that's the entry point to the application. So when you run your application, CLR executes the code inside main method. And that's where everything kicks off. This method is declared as static, and that's something I'm going to cover later in the next section. Methods have input and output. So what goes inside parentheses is the input to the method, which we call parameter or argument. Note that parameters are optional, but in this case, in the default template, the main method has a parameter called args, which is of type string array. We're going to learn about string array in the next section. What you see before the method name is the return type, or the output of the method. Void in C# means nothing. That means this method does not return any value. It just contains some code. That's it. Also, note that C# is a case-sensitive language. So this main has to be with capital M. Otherwise, CLR is not going to find this method as the entry point of the application. Okay, and one last thing is note these curly braces. So wherever we have a block of code, we need to surround it with curly braces. So that is applicable for methods, for classes, and for namespaces. Alright, now let's write a very simple C# program. So let's go here. We have a class called console, which is used to read data from console or write data to it. It has a bunch of methods. We can access these methods using the dot notation. And here you see various members of this class. Methods are indicated by a purple cube. So beep is used to play a beep sound, or clear is used to clear the console. We're going to use the writeLine method. This method can optionally take a parameter. So I'm going to pass a string here. Hello world. Just that. And note that statements in C# terminate with a semicolon, as you see here. Now take a look at using system on the top. Do you see that it's highlighted, whereas the others are grayed out? The reason for that is, in this file, we're using a class called console, which is defined in the system namespace. That's why that using statement is active. We are not using any classes defined in other namespaces, and that's why they're grayed out. So we can get rid of them to make our code cleaner. We can either delete each one by Ctrl X, like that. Or if you're using ReSharper, you can get rid of all of them by pressing Alt and Enter here, and selecting the first option, which is Remove Unused Directives in File. So it's faster. Now let's run the application with Ctrl and F5. So this window that you see here, this black window, is what we call console. And that's why this kind of project is called console application. Okay, that's it for this lecture. From this point, in every lecture, we're going to learn something new about C#, and we can write more interesting and more complex programs. I hope you enjoyed this lecture, and thank you for watching.
Okay, this section is going to be the first step in your journey to learn C#. So I'm going to introduce you to variables and constants. I'm going to talk about various data types and type conversion. I'm going to talk about scope and overflowing. And finally, I'm going to talk about various operators we have in C#. So let's get started.
Okay, we're going to start our journey by learning about variables and constants. Let's start by two definitions. A variable is a name that we give to a storage location in memory, where we can store a value. And a constant is an immutable value. That is a value that we know at compile time, and that value cannot change throughout the life of the application. Why do we use constants? The reason for that is to create safety in our application. Imagine you're creating an application that involves some mathematical computation around circles. We have this number called p, which is 3.14, and we use that to calculate the area of a circle. That number should always be the same. We don't want to accidentally change that in our program. If we accidentally change that, everything is going to blow up in terms of the results the program produces. So we declare that number as a constant. And this way we create safety in our application. In C#, to declare a variable, we start with a type, followed by an identifier, and finally, semicolon. Here, int represents integer, which is a number between -2 billion and +2 billion. Later in this video, I will show you all the primitive types that you need to know. Also, note that C# is a case-sensitive language, which means in this case, these two identifiers are different. One has lowercase n and one has uppercase n. When declaring a variable, we can optionally assign it a value, like what you see here. You don't have to, but there is one thing you need to know about variables, and that is you cannot use a variable unless you initialize it. So let's say if I declare this int number here and I decide to display it on the console, my application will not be compiled. I have to assign it a value before I can use it, before I can read it. I will show you that later when we jump to coding. To declare a constant, we start with the keyword const. Next we have the data type and an identifier, and here we have to initialize it with some value. We cannot define a constant without setting its value. There are a few things you need to know about identifiers. First one is that an identifier cannot start with a number. So you cannot have an identifier like the one you see here. Instead, you need to replace 1 with the word 1. Also, an identifier cannot include whitespace. So you cannot have an identifier like first space name. It has to be one word. An identifier cannot be a reserved keyword like int that you saw earlier. If you're desperate to use a word that coincidentally clashes with one of the C# keywords, you can prefix that with the @ sign. And finally, as a recommendation, always use meaningful names. For example, avoid a name like FN. Instead, use first name. This way, your code will be more readable, more maintainable, and cleaner, and everybody will understand that. In terms of naming convention, here are 3 popular naming conventions that have been around in the C language family. We've got camel case, Pascal case, and Hungarian notation. With camel case, as you see I have bolded here, the first letter of the first word is lowercase, and the first letter of every word after has to be uppercase. With Pascal case, the first letter of every word has to be uppercase. With Hungarian notation, we prefix the name of a variable with the data type it uses. So here str represents a string. Hungarian notation is not used in C#, and I have noticed programmers coming from C or C++ background use that in their code. If you're one of them, I highly recommend you not to use Hungarian notation because C# developers are not used to that and they don't like to see Hungarian notation in the code. It makes your code look a little bit ugly. So in C#, to name your local variables, use camel case. So as you see here, the first letter of the first word is lowercase, and if we had more words here in the identifier, the first letter of every word had to be uppercase. For constants, use Pascal case. So here you see I've got a constant here, constant integer, and the first letter of every word is uppercase. Here is the list of most commonly used primitive types in C#. In fact, the actual list is slightly bigger than this, but I deliberately decided not to include those data types because they're hardly ever used. In fact, they are there for interoperability with other languages. I personally, over the past 12 years of me coding in C#, I've hardly ever used them. In fact, never. So I decided not to confuse you with too much details that you don't need. In the next slide, I've got a link here in case you want to learn about the other primitive types. So let's take a look at the table here. On the left side, I have divided these data types into 4 categories: integral numbers, real numbers, character, and Boolean. This column shows the C# data types, and these are C# keywords. Note that C# keywords are always lowercase. Each of these C# keywords or C# types maps to a type in .NET Framework, which is displayed in this column. So these types are part of the .NET Framework. And when you compile your application, the compiler internally would translate the C# keyword you use here to equivalent .NET type. The third column here shows the number of bytes each data type uses, and I have listed these data types from the smallest to the largest in each category. So in the category of integral numbers, you see byte is the smallest, it takes only 1 byte, whereas long is the largest and it takes 8 bytes. The more bytes we have, the more storage we have, and we can store larger numbers. You don't really have to memorize the range of each data type, but remember, byte can store a value between 0 to 255. Short can store a value between minus 32,000 to plus 32,000. Integer can store a value between minus 2 billion to plus 2 billion, and long is even bigger than that. In terms of real numbers, we have 3 data types: float, double, and decimal. Float maps to the single type in .NET Framework, and it takes 4 bytes. And as you see, it can store a very large number. Double is twice as big, so it uses 8 bytes. And decimal uses 16 bytes. The more precision you need, the bigger data type you use. We also have character, which is represented by char keyword, and it's 2 bytes. So characters in C# are Unicode. And finally, we have bool, which represents Boolean, which can be either true or false. In case you want to learn more about the other data types that I told you they're not really used, you can simply go to Google and search for C# built-in types, and the first page is the MSTN page that lists all the primitive types in C#. Most of these data types are pretty straightforward, but there is something tricky about real numbers. In this table, I have listed the data types we have for real numbers: float, double, and decimal. I've highlighted double because that's the default data type used by its C# compiler when you're using real numbers. So if you want to declare a float, you need to explicitly tell the compiler to treat the number you have as a float. Here's an example. I've declared a float, call it number, assign it 1.2. Here I have added the suffix f, and that is to tell the compiler to treat this number as a float. If I didn't have this f here, compiler would think 1.2 is a double, because double is the default data type for real numbers. And of course, I cannot assign a double number into a float, so the program would not compile. Same applies to decimals. So if you want to declare a decimal, you need to add the suffix m at the end of the number. In C# we also have a few other types which are not considered primitive types, and they are string, array, enum, and class. You'll learn more about them throughout this course. Okay, that's it for this lecture. In the next lecture, we're going to talk about the concept of overflowing. I hope you enjoyed this lecture, and thank you for watching. Okay, now let's talk about the concept of overflowing. Here I've declared a variable of type byte, call it number, and assign it to 255. As I told you earlier in the slides, 255 is the largest value you can store in a byte. Now in the next line, I'm increasing the value of number by 1 and trying to store 256 in the number. But if you compile the application and display number on the console, you will see 0. And this is what we call overflowing. So we have exceeded the boundary of the byte data type. In C#, by default, we don't have overflow checking, which means we can modify the value of a variable at runtime, and if we go beyond the boundary of its underlying data type, we will get overflow. Now, sometimes this is not desirable in your application. You want to stop overflowing. If that's the case, you need to use the checked keyword. So here is how it works. We have the checked keyword, followed by curly braces, which indicate a code block. And inside that block, we have the variable declaration and any kind of arithmetic operations. With this code, overflow will not happen at runtime. Instead, an exception will be thrown, and the program will crash unless you handle the exception. The topic of exceptions is an advanced topic, and I have covered it in my C# Advanced course. For now, all I want you to know is that if you use the checked keyword, overflow will not happen, and instead, the program will throw an exception. Now, do we really need that in reality? Honestly, I have never ever came across this situation. Because if I was concerned that in this case my number variable would overflow, I would just simply use the short data type instead of byte. But I decided to include the concept of overflowing because I wanted my C# course to be comprehensive. So just be aware of that in case you hear about overflowing somewhere, but you're probably not going to use that in the real world. In the next lecture, we're going to talk about the concept of scope. Okay, let's talk about the concept of scope. What is a scope? Scope is where a variable or a constant has meaning and is accessible. Take a look at this block of code here. As you know, a block is indicated by curly braces. Here we have 3 blocks of code. Here's one, here's another, and here's the last one. Inside the first block, I've got a variable called a. And a is accessible anywhere inside this block or any of its child blocks. If I go out of this block and try to access a, the program will not compile. The same rule applies to other variables. So let's take a look at this block here. B is meaningful anywhere inside this block or any of its children. If I go outside this block and try to access B, I'm going to get a compile time error. Okay, I think that's enough theory for now. Let's open up Visual Studio and do some coding. Okay, let's start by declaring a variable of type byte and call it number. Now we want to display it on the console. So as you remember from the last lecture, we type console.writeLine and put the variable here. Note that as I was typing console.writeLine, my ReSharper plugin automatically added this using statement on the top. System is a namespace, and console is a class that is defined in the system namespace. So in order to use the console class, we need that declaration here on the top. If you're not using ReSharper, you have to go here and manually type using system semicolon. Okay, now take a look at this number here. It has a red underline. And if we put the mouse cursor here, it says local variable number might not be initialized before accessing. If you remember from the slides, I told you in C#, before you can access a variable, you need to set it. You need to initialize it. And that's the reason here we have the red underline. We cannot display the number on the console before initializing that. So if I try to compile the application, we're going to get an error. To compile an application, you press Ctrl, Shift, and B. And here is the error list. Use of unassigned local variable number. We can solve this problem by initializing number, like setting it to 2, for example. And you see the red underline is gone. We can compile again, Ctrl, Shift, B. Build succeeded, take a look here. Okay, now we can run the application by pressing Ctrl and F5. Okay, so we got 2 on the console. Now let's extend this example and declare a few more variables. We can define an integer, int count equals 10, and a float, say total price equals $20.95. Now note this red underline here. Let's find out what's happening here. So I put the mouse cursor here. It says cannot convert source type double to target type float. If you remember from the slides, I told you by default the C# compiler treats real numbers like this one here as double, whereas we are declaring a float. So here we need to explicitly tell the C# compiler to treat this real number as a float, and we can do that by appending an F at the end. So the error is gone. Let's declare character. So char character equals A. Note that in C# we enclose characters by single quote, like here. We can also declare a string. String is not one of the primitive types, and I have covered it in a separate lecture in this course. But for now, let me show you how to declare a string. We just type string, give it a name, first name equals Mosh. Note that with strings, we enclose them in double quote. So that's one of the differences between strings and characters. And finally, let's declare a bool. Bool is working equals true. So with bools, we can either set them to true or false. Both true and false are keywords. As you can see, they're indicated by the blue color here, and they're lowercase. So everything you see here that is blue is a keyword, like static, void, string, class, namespace, and all these data types here. Now let's display these variables on the console. So let me show you a trick. Instead of writing console.writeLine, we can do a shortcut. This is what we call a code snippet. So we type CW, that is short for console, writeLine, and then press tab. And Visual Studio automatically converts that to console.writeLine. There are various code snippets that help you write code faster, and I will try to point them out throughout this course. So let's display count. Now another one. Total price. And note that I can just type TO, and here's what we call IntelliSense. It's Visual Studio's auto-completion mechanism. You don't have to type the full name of a type or a variable. As long as the IntelliSense detects that and is highlighted here like total price, you can simply press tab, and there you go. Visual Studio automatically completes that for us. Let's display the character. Same here, I just press tab. Again, I typed only a few characters. You can press tab or enter. And finally, it is working. We run the application by Control and F5. So we got all these values on the console. Okay, now let me show you something else. In C#, we have a keyword called var, which makes variable declarations easier. For example, here, instead of explicitly specifying the data type for each of these here, I can simply type var. And I let the C# compiler detect the data type for this variable here. So let me replace all of this with var. Okay, now if we hover the mouse over the var keyword, we can see the underlying data type. In this case, it's system.boolean, which is the .NET type, which maps to C# bool keyword. How about this one? That's a string. And this one is a character. And this one is system.single, which maps to float in C#. And in the case of count, it's int32, which is integer. And same for number. So the tricky thing here is, by default, C# treats integral numbers as integer. And when you use the var keyword, it assumes that it's an integer. If you really want to go for a byte, then you have to explicitly specify it as byte here. But telling you from experience, it's safe to use integer in most cases. In fact, if you look at the classes in the .NET framework, in most cases, integer is the data type used for representing integral numbers. Okay, I revert this back. Now I show you something else. So let's take a look at this one here. So it's a char, which is a character. We can put the mouse cursor here and press Control and then click. That opens the Object Browser window. Take a look here, it's Object Browser. And it's a way to look at the various classes in your project or in the .NET framework. In this case, because I did a control click on the char or var keyword, this is what we got here. So char is highlighted in the Object Browser. On the right side, you see all the members of the char type. So these purple ones are functions or methods. If you scroll down here, you see two fields here, min value and max value. We'll explore them shortly. And note that here is the declaration of char. Char is a structure. We will cover structures later in this course. And note that it's a member of system namespace. You can click system, and that shows the system namespace as well as all the types defined in the system namespace. So these are part of the .NET framework. Okay, let's close this for now. Let's explore another example. So I'm going to get rid of all the code here. We can simply press Ctrl X on each line. And that deletes all these lines here. Okay, let's do a console the right line. So CW, tab. This time I pass a string here. And I specify two placeholders. And finally, supply a couple of arguments. Okay, let's see what's going on here. So here, what we have is called a format string. It's a kind of string that can be used as some kind of template. So at runtime, what we have here, indicated by curly braces and 0 as the argument, will be replaced by the value we pass here. So 0 represents the first argument after this format string. And 1 represents the second argument after this format string, in this case, byte.maxValue. So let's run this application. We got 0 and 255. And that's the range that you can store in a byte. We can do the same with a float. So CW, tab, a format string, float, main value, float, max value. Run the application. So this is the range we can store with a float. It's a huge number that is displayed using the scientific notation. Okay, now let's take a look at constants. So I get rid of these two lines here. Control X, Control X. We define a constant with the const keyword. Const float p 3.14, and we have to put f at the end because it's a float. Now, because we declared p as a constant here, I cannot change it in my program. So I cannot go here and say p equals 1. The compiler is not happy, and that's why we see that red underline here. If you hover the mouse here, it says, read-only local constant cannot be used as an assignment target. It's a little weird expression to understand, but basically, the intention of using constants is to have some kind of safety in your program. So if there are values that should not be changed throughout your program, you define them as constants. And this way, you won't accidentally modify their values. In this video, I'm going to talk about various kinds of type conversion in C#. We have implicit type conversion, explicit type conversion, which is also called casting, and we also have conversion between non-compatible types. Here is an example of implicit type conversion. A byte, as you know, takes only 1 byte of memory, and an integer takes 4 bytes. So we can easily copy a byte to an integer. What happens at runtime is, let's take a look at this slide. So here's the binary representation of our b variable here. So 1 is represented as 7 bits of 0 and 1 bit of 1. When we copy a byte to an integer, what the runtime does is it prefixes that value with a bunch of zeros to fill the 4 bytes. So there is no data loss. In situations like that, when the compiler is 100% sure that the types are compatible and no data loss will happen, values can be converted to a different type implicitly. Here's another example of implicit type conversion. So we have an integer, set it to 1, and we copy that to a float. Again, in this example, no data loss will happen. But let's take a look at this one. Here we have declared an integer, and we're trying to copy that to a byte. An integer is 4 bytes. So when we convert that to a byte 3 bytes out of 4 bytes will be gone. And there is a chance for data loss. Now, data loss doesn't always happen. It only happens if the value we stored in the integer is beyond the capacity of a byte. In this example, 1 can be stored in a byte, so no data loss will happen. But if we had, let's say, 300 here, we cannot store 300 in a byte. So as a result of that conversion, data will be lost. When the compiler knows that there is a chance for data loss, it doesn't allow implicit type conversion. And you need to explicitly tell the compiler that you're aware of the data loss and you still want to go ahead with the conversion. In situations like that, what we do is we prefix the variable with the target type. So here, I'm trying to convert I to a byte. This is what we call as casting. Here is another example. So we have a float set to 1.0. And if we try to convert that to an integer, the compiler would complain. I will show you that later in the coding demo. So we need to tell the compiler that we are aware of the data loss and we still want to convert f, which is a float, to an integer. So we cast it, like here. Sometimes we are working with types that are not compatible, but you still need to convert them. For example, we might have a number represented as a string, as you see here, and we need to convert it to an integer. In situations like that, because string and int are not compatible, we cannot use explicit casting. So we need a different mechanism for converting a string to a number. In situations like that, we need to use the convert class or use the parse method. So convert class is part of .NET Framework and is defined in the system namespace. It has a bunch of methods for converting various types to other types, and they all start with 2. In this case, we're trying to convert s, which is a string, to an int32. Int32, as you know, is a .NET Framework type which maps to a C# integer type. Remember, a byte is 1 byte, a short is 2 bytes, an integer is 4 bytes, and a long is 8 bytes. You probably know that each byte has 8 bits. So an integer which has 4 bytes times 8 bits ends up being 32 bits. That's why it's called 2 int32. And int16, which represents 16 bits, equals to short, which is 2 bytes. We also have this parse method here. All the primitive types that I explained in the last lecture, like integer, long, float, boolean, they all have this parse method. And the parse method takes a string and tries to convert that to the target type, in this case an integer. Here are some of the methods that you can find in the convert class. To byte, which converts the given value to a byte. To int16, to convert the given value to a short. To int32, to convert the given value to an integer. And to int64, to convert the given value to a long. Okay, enough theory, let's jump into code and see all this concept in action. Okay, let's see implicit type conversion in action. First, I declare a byte, call it b, and set it to 1. Now I declare an integer, and set it to b. Again, to recap, a byte is only 1 byte, and an integer is 4 bytes. So we can copy b to I without data loss. And as you see, there is no compile time error here. Let's put I on the console. So console.writeLine. And we pass I here. Note that as I typed console.writeLine, my ReSharper plugin automatically added this using system statement on the top. Again, if you don't have ReSharper, you need to go manually add this statement here. We run the application by Control and F5. So we got I on the console. Now let's reverse this and see what happens. So I'm going to get rid of this code here. Control X, Control X, Control X. First, I declare an integer, set it to 1. Then I declare a byte and try to copy I to B. We immediately got this red underline here. If you hover the mouse here, the tooltip says cannot convert source type int to target type byte. Sometimes this error might be in a different file which is not open in Visual Studio here. So you may see the error when compiling the application. Let's simulate that. So I compile this application by Control, Shift, and B, which stands for build. So here's the error. Cannot implicitly convert type int to byte. An explicit conversion exists. Are you missing a cast? So now you understand the concept of implicit versus explicit type conversion. So what we need to do here is to do a cast. So we cast that integer to a byte. Now in this case, no data loss will happen because the value is small enough to be stored in 1 byte. Let's put b on the console. Console.writeLine b. We run the application. So everything is good. But let's see what happens if we set I to, let's say, 1000. We cannot store the number 1000 in a byte. The maximum we can store in a byte is 255. So if we run the application now, we got 232 because some of the bits were lost. And this is the reason that C# compiler knows that there is a chance for data loss, and it enforces you to explicitly specify the cast. Sometimes you know that despite the differences in data types, there is no chance of data loss, like in the last example where I was set to 1. In those cases, you can safely apply a cast. Okay, now let's take a look at non-compatible types. So let's clean up this code. I start by declaring a string. Let's call it number and set it to 1, 2, 3, 4. Just recapping from the last lecture, note that here I could declare this with the var keyword. And C# compiler automatically detects that this is a string, so number will be defined as a string. And we can see that by hovering the mouse here, it says system.string. Now let's say we want to convert that to a number. If I declare an integer, like I cannot cast that number to an integer because they're not compatible. Let's take a look at the error. Cannot cast expression of type string to type int. So if you see that error, that's the time when you need to use the convert class. So we type in convert dot. Take a look at these methods here. To byte, to char, to int16, to int32, and many other methods here. So let's convert that to an integer, which is int32, and pass number as an argument here. Now let's print out the I on the console. Run the application. So I is 1, 2, 3, 4, all good. But let's see what happens if instead I declare this as a byte. And here we need to use convert.toByte. And here we display B on the console. A byte does not have enough storage to store the value of 1234. So when we run the application now, the application crashed. We cancel this here. And here's the exception. Exception is .NET Framework's error reporting mechanism. It's an advanced topic and I have covered it in detail in my C# Advanced course. But in this video, I will briefly show you how to handle exceptions. So here it says on handle exception, the type of exception is system.overflowException, which means we try to store a value that was too large or too small for a byte. So each exception or error has a type, in this case overflow exception, and has a message. Value was either too large or too small for an unsigned byte. Sometimes the exception messages are friendly enough that are easy to understand. Sometimes they're a little bit tricky, and the best way to work out what is going wrong is to jump on Google and search for the error, and there's pretty much always a Stack Overflow page that explains that. Now let's discard that. Let's see how to handle the exception here. So the exception happened during conversion of that string to byte. What we need to do here is to wrap these few statements with a try-catch block. Let's see how it works. So I just typed try and pressed enter, and Visual Studio automatically generated this block for me. Again, this is what we call a code snippet. Let me undo this and show you one more time. So try, see this try here in the IntelliSense, and this icon represents a code snippet. So if I press Enter or Tab, you automatically get this code block. So what I'm going to do now is to move this code into the try block, and the catch block gets an exception. By default, Visual Studio has this throw here. Don't worry about it, just delete it. Again, I will explain it in detail in my C# Advanced course. For now, let's see what's going on here. So the code that you put inside the try block will be somehow monitored, and if an exception happens, this block will be executed. This prevents your application from crashing. The reason our application crashed earlier was because we did not handle the exception. So if you don't handle the exception will be propagated to the .NET runtime, and .NET runtime's mechanism is to stop your application and display the error. Here we can handle the exception, and that would prevent the exception from being propagated to .NET runtime. So instead we can display a friendly message to the user, saying, for example, console.writeLine, the number could not be converted to a byte. Now let's run the application again. See, we got the friendly message and the application didn't crash. So what I want you to take away from this lecture is this convert class works pretty well in most cases, but in cases where the source type cannot be converted to the target type, there is a chance for exception, and you need to be aware of that. And what you need to do is to wrap this block of code with try catch. Let's take a look at one more example before we finish this lecture. Let's remove this and instead define a string, call it str, and set it to true. We can use the convert class to convert that value to a boolean. So bool b equals convert.toBoolean, and we pass that str here. Again, in this example, string and bool are not compatible, and that's why we cannot use explicit casting. So here we are using the convert class. We can display b on the console. Let's run the application. So the true string was successfully converted to a boolean value. Okay, that's pretty much it for this lecture. Before I finish, I just need to emphasize something here, that throughout this course, during early lectures, you may see me using some short variable names like b or str here. That's purely for demonstration and keeping things simple. And in building real-world applications, we should really avoid naming our variables a, b, c, str. It's not really a good practice. The only exception is when we get to loops, which you will see later in this course. In for loops, we use counter variables and we call them I or j. It's a common convention. Now here we are just starting to learn C# and it's really impossible for me to demonstrate building a real-world application because we're just covering the basics or alphabets. I hope you enjoyed this lecture and thank you for watching. Okay, we got to operators. In C# we have 5 types of operators: arithmetic, comparison, assignment, logical, and bitwise. Let's take a closer look at each of these operators. We use arithmetic operators in computations where we're working with numbers. So as you see in this slide, we have add, subtract, multiply, divide, and remainder of division. We also have 2 arithmetic operators called increment and decrement, which are shortcuts for adding 1 or subtracting 1 from a variable. So a++ is equivalent to a equals a plus 1. Now with this increment and decrement operator, there are 2 ways you can apply them. You can use them as a postfix. So in this example, a is 1, and when we apply the postfix increment operator, first the value of a is assigned to b, so b is going to be 1, and then a is incremented by 1. So in this example, after the second line is executed, a is going to be 2, and b is going to be 1. Now let's take a look at a different way of applying increment operator as a prefix. So in this example, In the second line, first A is incremented by 1, and then it's assigned to B. So after the second line, both A and B are going to be 2. So be aware of this difference. Okay, next, comparison operators. So we got equal, which is indicated by double equal sign, not equal, greater than or equal to, less than, and less than or equal to. Now, what I want you to pay attention to in this list is that the testing for equality is accomplished by double equal sign. And that's different from a single equal, which is the assignment operator. Next, assignment operators. So the most commonly used is the one with a single equal sign. So here we set A to 1. Pretty basic. Now look at the next 4 types of assignment operators: addition assignment, subtraction assignment, multiplication assignment, and division assignment. Let's see how they work. For example, addition assignment. A plus equal 3 means add 3 to A. So it's equivalent to writing A equals A plus 3. And the same rule applies to other 4 assignment operators. Logical operators are used in Boolean expressions, which are often used in conditional statements. We'll get to conditional statements later in this course. So a real-world example is where you have a condition and you want to make sure that condition and another condition both are true, or maybe one of them is true. So that's where you use a logical operator. In C#, the logical AND is indicated by double ampersand, and the logical OR is implemented by double vertical line. We also have the NOT operator, which is indicated by an exclamation mark. And finally, here we've got the bitwise operators. Bitwise operators are often used in low-level programming, like when working with Windows API, or in sockets, or encryption. Explanation of these is beyond the scope of this course. But if you're interested, let me know and I write a blog post for you. Now, what I want you to take away here is that the bitwise AND is indicated by a single ampersand, whereas the logical AND, which we use in conditional statements, is indicated by double ampersand. Same for bitwise OR and logical OR. So remember the difference. Okay, enough theory. Let's flip over to Visual Studio and see all these concepts in action. Okay, let's start with the arithmetic operators first. So I define 2 variables, A equals 10, B equals 3. Let's add them together and display the results in the console. That's pretty easy, right? Run the application. So the result is 13. Now let's take a look at division. So I replace the add operator with division. The result is 3. The interesting thing here is because both A and B are integers, the result of the division ends up being an integer. If you like a floating point number as the result of the division, you need to cast both these numbers to a float. So, like this. Now if you run the application, the result is a floating point number. Now let's look at a more tricky example. Let's say C is 3, B is 2, and A is 1. I want to show you the concept of operator precedence. So if I type A plus B times C, what do you expect the result to be? From a mathematical perspective, B should be multiplied by C first, which means 2 times 3 equals 6, and then it should be added to 1, so the result should be 7. Let's run the application. So C# behaves exactly as what we expected. So multiply or division operators have higher precedence than add or subtract. If you like to change the precedence, you can do so by using parentheses. So in this case, if you would like to have A and B added together first, and then multiplied by C, this is how we would achieve that. In this case, the result would be 9. There you go. Okay, now let's take a look at comparison operators. So let's get rid of C here, and instead see if A is greater than B. Very simple example, right? The result is false. So what I want you to know here is the result of a comparison expression is always a Boolean value, which is true or false. We can test for equality. So double equal sign. In this case, A is not equal to B, so the result should be false. Now let's see the not equal operator. So simply have an exclamation mark here, followed by an equal sign. In this case, because A is not equal to B, the result should be true. Okay, now let me show you a more tricky example. What do you expect here? Well, first, this is the not operator, which is applied on Boolean values or Boolean expressions. In this case, this is a Boolean expression, and as you saw earlier, it was true because A is not equal to B. So we apply the not operator to that, and the result ends up being false. Let's run the application. So we got false here. But this code is not easy to understand or easy to read, because here we have two negatives. One negative and two negative. And for us humans, two negative is hard to comprehend. Two negatives always equal to one positive. So in your program, if you end up in situations where you have two negatives, make sure to always inverse them with one positive. So in that case, I can get rid of the first negative and convert the second negative to a positive like that, and we will get the same result, which is false. Now let's take a look at logical operators. So I create another variable here, var c equals 3. I'm going to change that to c greater than b and c greater than a. What do you expect here as the result? Well, c is greater than b, so the result of that expression is true. Also, c is greater than a, so the result of that expression is true as well. And here we have the AND operator. So true and true equals to true. Let's run the application. There you go. Now let's make a tiny change here. So this time, because we know c is not equal to a, this expression evaluates to false. True and false results in false. Let's run the application. So we got false. Now let's see the effect of the OR operator. So I'm going to replace the AND with OR, which is double vertical line. In this case, that is true or false. The result ends up being true. And of course, we can apply a NOT operator here, as you saw earlier, which changes the true to false. Now, this expression doesn't really look easy to understand. It's just purely for demonstration of how we can combine different operators and make up more complicated expressions. Okay, that's it for this lecture. I hope you enjoyed it, and thank you for watching. Okay, so we got to comments. A comment is text that we put in our code to improve its readability and maintainability. In C#, we have two ways to write comments. If your comment is only a single line, you can prefix the comment with /. But if your comment is longer and it's multiple lines, you need to start it with /* and then finish it with */. This type of comment is more like the comments we used to write in C and C++ code. These days, it's more conventional to write either single line or multi-line comments prefixing with /. So in this example, we can rewrite this multi-line comment with // style like this. Now, as a rule of thumb, keep your comments to minimum. Use comments only when required, and that's when explaining whys, hows, constraints, and things like that. Do not explain what the code is doing. Your code should be so clean and straightforward that it doesn't need comment. If a comment explains just what the code is doing, it's redundant. And the problem with redundant comments is we change the code, but not everyone is very consistent in changing the comments. So after a while, these comments become outdated. And because they don't get compiled like the code, there is no way to validate them, and after a while, they become useless. So again, keep them to minimum and explain whys, hows, and constraints that you had at the time you wrote the code, so the next person who is reading your code knows the reason why you wrote the code that way.
In this section, you learned that C# is a statically typed language, which means once you declare a variable, you need to specify its type, and that type cannot change during the lifetime of that variable. You also learned about the primitive types in C#, such as integer, character, boolean, and so on. Now in the next section, I'm going to introduce you to non-primitive types in C#, such as classes or structures, arrays, strings, and enums. So I will see you in the next section. In this section, I'm going to talk about non-primitive types in C#, such as classes, structures, arrays, strings, and enums. And then I'm going to talk about a very important topic called reference types versus value types, which is about memory management of different types in C#. So let's get started.
Earlier in this course, you learned that classes are building blocks of our applications. These classes combine related variables or fields and functions together. So here's an example. In this picture, we have a class called person with 4 fields: name, age, height, and weight. And it also has 4 methods or 4 functions: walk, talk, eat, and sleep. This class is a type or a blueprint from which we create objects. So an object is an instance of a class. In this example, we can create 3 instances of this person class, like John, Mary, and Scott. So more accurately, when you run your application, it's these objects that are talking to each other and collaborating to provide some functionality. But the word class and objects are often used interchangeably. Okay, now let's see how we can create a class in C#. So to create a class, we start with an access modifier, and then the class keyword, and an identifier. An access modifier determines who can access this class. For now, don't worry about it because that's something I have covered in my C# intermediate course, which is the second part of this course. Just remember, whenever you want to create a class, use the public keyword to make that class accessible anywhere in your application. Inside the code block for the class, we can have variables, which we call fields. Also note that when we declare a variable, we need to specify an access modifier. Again, for all examples in this course, we're going to stick to public, and in the next course, we'll take a look at other access modifiers. Note that in C#, anywhere you have a statement, like a variable declaration here, you need to terminate that statement with a semicolon. But you don't have to do that when you have a code block. Your classes can also contain methods. So here is an example. In this example, void is the return type for the introduce method, which means this method does not return any values. And also note that this method does not take any parameters, as indicated by empty parentheses. So it simply outputs the name of the person on the console. Here is another example. In this example, we have a calculator class with 1 method, which takes 2 parameters of type integer and returns an integer. Now that we have a class, let's see how we can create an object. So earlier, you learned that to declare a variable, you start with a type and then an identifier. Creating objects or instances of classes is pretty similar. We start with a type and an identifier, but there is one more step. We need to allocate memory for that object, and that's when we use the new operator. So in C#, classes are treated differently than primitive types. So you need to explicitly allocate memory for them. But the good thing is, unlike languages like Objective-C or C++, you do not have to worry about deallocating that memory. CLR, or Common Language Runtime, will take care of that for you. It has a process called garbage collection, which automatically removes all objects that are not used. So to allocate memory to an object, use the new operator and then repeat the type of the class and parentheses. You can make this code a bit shorter by using the var keyword that you learned earlier. And now that we have a person object, we can access its members like name field or the introduce method using the dot notation. So in this example, I set the name of this person and then call the introduce method. Now let's see what is that static modifier that you saw in our first C# program. So here is the calculator class that you saw earlier. We can modify this add method with the static keyword like this. And as a result, we can access that method directly via the calculator class itself. We do not have to create an object to access a static member. In fact, we cannot access static members from objects. So what is this all about? Why do we need this? Well, let me show you what's happening behind the scene, and then you will have a better understanding of this. So without the static modifier, when you create 3 objects of this calculator class, each object in the memory will have the add method. But when you apply the static modifier, that add method will be only in one place in memory, and that is the calculator class itself. So it's not going to be repeated 3 times in memory. But why do we need this? We use the static modifier when we want to represent a concept that only a single instance of that should exist in memory. Here is an example. Remember the program class in our first C# program? So there we had a main method, and main was modified with the static keyword, which means there is only one instance of the main method in memory. There is only one entry point in each C# application. Current datetime is another example. You don't want to have multiple datetime objects in memory, each representing a current datetime. You want only one place in memory where you can look at the current datetime. So all I want you to know for now is that when you modify any members of a class, whether it's a field or a method, with a static modifier, that member will be accessible from the class itself, not an object. Well, that's enough theory for now. Let's flip over to Visual Studio and do some coding. Okay, here I have a blank console application and I want to create a class called person. So we can't create a class here inside the main method because that's a function or a method. So we need to create a class at the namespace level. So look, here we have a namespace and here's one default class. We can create another class at this level. So public class person, code block. Now let's declare a couple of fields. So public string first name, public string last name. And now let's declare a method, public void, which means it doesn't return any values, introduce. And here I simply use console.writeLine to output the full name of this person on the console. So console.writeLine, my name is first name plus, I would like to add a space between them, and last name. Now let's create an object of type person. So we go to the main method. We can start with person. Let's call this John equals new person. And note the green highlight here. ReSharper is suggesting to use var to make this code a bit shorter and cleaner. So I put the cursor here, Alt and enter, and enter. Now let's set the first name and last name for this object. So John dot first name equals John. John dot last name equals Smith. And now we can call the introduce method. Let's run the application with Control and F5. So my name is John Smith. Okay, now let me show you something. When you write a real-world application, you're going to have tens, hundreds, or even thousands of classes. So you're not going to put all of these classes inside this file here. Otherwise, the file will explode. So we want to have one class per file. If you have ReSharper, you can easily move this class to a new file. So all you do, you put the cursor on the class name, press Alt and Enter, and note the first option, move to person.cs. Enter. What happened was ReSharper automatically created a new file called person.cs and moved this class from program.cs file, which was here, inside the new file. So I didn't have to go manually create a new file and type the name of the class there. But if you don't have ReSharper, that's perfectly fine. So to add a new class to your project, go to Solution Explorer, right-click on your project, then go to Add. Actually, you can see that here. Let me drag this Solution Explorer to the left. Okay. Now, right-click, Add, Class, or you can use the shortcut Shift, Alt, and C. Now, in this dialog box, type the name of your class. Let's say Calculator. That's it. Now you got a new file here, calculator.cs, and here's a class. Note that in this example, because the name of my project is C# Fundamentals, every time I create a class, by default, it's added inside the C# Fundamentals namespace. In the introduction of this course, I explained that we want to group related classes inside different namespaces. So perhaps the concept of person is different from calculator. Calculator is more about math, whereas person could be part of a commerce application. So a better way is to right-click the project, go to Add, New Folder. We create a new folder like Math. Then we move this calculator class there. Confirm. The only problem is when you move, the namespace is not changed by default. So you need to go here, manually add .math here. Or if you have ReSharper, you don't have to even type that. You can put the cursor on the namespace and press Alt and Enter and Enter. And that automatically updates namespace to C# Fundamentals.math. So here's our calculator class. First, we add the public keyword so that it's accessible. Note that if I don't add that, and I go to program.cs, I'm not going to be able to create a new instance of calculator. So if I type calculator, see, IntelliSense cannot find that class because it's not accessible. Now we go to calculator, add the public keyword here, back to the program. And ReSharper is suggesting to import that calculator class, which means adding a using statement on top of this file. So with ReSharper, I can press Alt and Enter, and that would automatically add this using statement here. But if you don't have ReSharper, you have to go on top of the file, manually type the name of the namespace where that class is declared. So using C# Fundamentals.math. So you see, ReSharper makes coding a lot easier. You don't have to worry about these namespaces. What class is in what namespace? And you don't have to type them. You just type the name of your class and let ReSharper do all the plumbing for you. Okay, now we have a calculator class. Let's create an object. And we use the new operator to allocate memory to that object. And I just realized that we didn't add any methods to this class. So let's get back there. Let's create a new method called add, which returns an integer and takes two parameters, a and b, and it simply adds them together and returns them. Now we save the file with Ctrl and S, get back to program. A quick way of doing that is you press Ctrl and Tab, and you can switch between the open windows in Visual Studio. So you don't have to grab the mouse every time and click these tabs on the top. You can do everything with your keyboard. So back to program.cs. And here we call the add method. We pass two arguments, 1 and 2. We can store the result in another variable, var result equals, and we can output that variable on the console. So console.writeLine result. And now let's run the application with Control and F5. So the result is 3. Now, before we finish this lecture, I want to show you something interesting here. Look, every time we use console.writeLine, we access that method directly on the console class itself. What does this mean? That means the writeLine method is defined as static. We don't have to go and create a new console object in order to call the writeLine method. So you already used a static modifier before without being aware of that. In this case, all methods of the console class are declared as static because we only have one console when we run the application. That's it for this lecture. I hope you enjoyed it and thank you for watching. In C# we also have another type similar to classes, which is called structure or struct. So in terms of syntax, it's very similar to a class. The only difference is instead of using the class keyword, we use the struct keyword. So similar to classes, structures combine related fields and methods together. But what is the difference? If you read the C# documentation, you're going to see lots of tiny differences between classes and structures, and you're probably going to be even more confused than when you started. I personally don't find these subtle differences very pragmatic. In fact, in the real world, 99% of the time, you will create new types using classes, not structures. The pragmatic guideline I give you in this lecture is use a structure when you want to define a small, lightweight object like this RGB color here, or if you're dealing with something like a point that has an X and a Y. You can certainly define that using a class. There is no problem at all. But if you're in a situation when you want to create thousands or tens of thousands of objects of that type, it's more efficient to define them as a structure. If not, don't worry about it, just stick to classes, because that's what you use most of the time. Another non-primitive type we have in C# is array. In this lecture, I'm going to give you a brief introduction of arrays to get you started. Later in this course, we have a separate section about arrays, and there I will cover more details. So what I'm covering in this lecture is what is an array, how to declare and initialize arrays, and how to access array elements. So what is an array? An array is a data structure that we use to store a collection of variables of the same type. For example, imagine you would like to work with 3 numbers. So instead of declaring 3 integer variables like number 1, 2, 3, you can declare an array and call it numbers. Note the square brackets here. The first one is used to tell the compiler that we would like to declare an array, and the second one is used to set the size of that array. So in C#, arrays have a fixed size, which means you need to specify it during declaration and it cannot be changed. Also note the new operator here. When declaring an array, you need to allocate memory for it, and that's why you need to use the new operator. Also, an array is an object behind the scene. So in C# we have a class called array, and when you declare an array using this syntax here, internally the compiler creates an instance of that class, so an object, and that's why we need to allocate memory for it. Now that we have an array, we can access its elements using an index that we supply in the square brackets. Note that in C# arrays are 0 indexed, which means the first element of an array has the index of 0. If you know ahead of time the values you would like to store in an array, you can use the object initialization syntax and make this code shorter. So during the declaration, we supply the values in curly braces. Again, this was a quick introduction to arrays, so you can get started quickly and write some simple programs. I'm going to cover arrays in more detail in a later section in this course. Now let's flip over to Visual Studio and do some coding. Okay, in this video, we're going to take a look at how to declare and initialize an array in C#. So let's say we would like to create an array of integers. So we start with int. We use the square brackets to indicate that we would like to create an array, not just an integer. We give it an identifier or a name. And now we need to allocate memory to it. So we use the new operator. And we repeat int array again. But this time we need to specify the size of the array. So let's say 3. Now we can make this code a bit shorter by getting rid of this int array here and just using var. The compiler knows that numbers is assigned to an integer array, as you see here. So there's no need to repeat that twice. Now I'm going to set the first element of this array. And because in C# arrays are 0 indexed, the first element starts with index of 0. So numbers of 0 equals 1. Now let me show you something. I'm going to display all the elements in this array on the console. So console the right line, numbers of 0. And I'm going to duplicate this line a couple of times with Control D, which is one of ReSharper's shortcuts. And I change the index on each line. So this is a very basic way of displaying elements in an array. A more efficient way is to use a loop, and that's something we're going to look at in the next section. Now let's run this application and see what happens. So our array has 3 elements, and the first one is initialized to 1. But what about the others? Note that they're initialized to 0 by default. So that means when you declare an array, all the elements are set to the default value of the data type for that array. In this case, because our array is of type integer, the default value for integers or any kind of numbers in C# is 0. If we had an array of booleans, all elements in that array would be initialized to false. Let's try that. So I'm going to create another array. Let's call it flags. And this time I'm going to use a bool array. Again, the same size. Again, similarly, I set the first element. So flags of 0 equals true. And now I display all elements in this array. Let's run the application. So note that the first element of the Boolean array is set to true, but the second and third elements are false. Now, one more example before we finish this lecture. This time, I'm going to create an array of strings, and I'm going to use the object initialization syntax to initialize it during declaration. So, I'm going to call it names, new string array of size 3, and I'm going to store 3 names here. So, Jack, John, and Mary. So with the object initialization syntax, you start with curly braces and you supply values for each element of the array. That's pretty much it for this lecture. Later in this course, we're going to have a full section on arrays, and there I'm going to cover arrays in more detail. I hope you enjoyed this lecture, and thank you for watching. Okay, in this video we're going to have a quick introduction to strings so you can quickly get started. And later in the course, we have a separate section where I cover more details about strings. So in this lecture, I'm going to cover what is a string, different ways to create strings in C#, and finally I'm going to talk about escape characters and verbatim strings, which are pretty handy. So a string is a sequence of characters. And as you can see in this example, in C#, we surround strings with double quote, as opposed to characters which are surrounded by single quote. There are different ways to create strings in C#. A very common way is to use a string literal. So just like declaring a variable, we start with a type, in this case string, then an identifier, and finally we assign it to a string literal. We can also concatenate strings using the plus operator. So in this example, I'm adding first name plus a string literal which represents an empty character, and finally the last name. Sometimes using string concatenation this way can create a bit of noise in your code. You might have different string variables that you're concatenating, and it's hard to visualize what the output looks like. If that's the case, you can use string format. So in C#, the string keyword maps to the string class in the .NET framework. And you learn that classes can have fields and methods. And we can declare these members as static, which means we can access them directly on the class without the need to create an object. So in the example you see here, we're calling the format method on the string class. Format is a static method, so we can directly access it using string.format. This method takes a couple of parameters. The first one is a format string, which we use to define a template for our string. Inside this template, we have placeholders. Placeholders are indicated by curly braces, and they are 0 indexed. So here, placeholder 0 will be replaced by first name, and placeholder 1 will be replaced by last name. So as you see in this example, it's much easier to visualize the output as opposed to concatenating multiple strings together. Sometimes you might have an array of objects. You can create a string from combining all elements of that array using a separator. So in this example, we have an integer array with values 1, 2, 3. And in the second line, we are calling the join method of the string class, which is a static method. And we supply 2 arguments. The first argument, which is a string, is a separator. In this case, I would like to combine these 3 numbers using a comma. The second argument to this method is the array whose elements we would like to combine. Now that we have a string, we can access each of its individual characters using an index. So in this case, name of 0 represents the first character in our string. One thing you need to know about strings in C# is that strings are immutable, which means once you create them, you cannot change them. So back to our example here, we can certainly read the value of the first character in our string, but we cannot change it. So the third line here, which is indicated by red, is not going to be compiled. There are methods in the string class that allows us to manipulate strings and modify their values. But all these methods return a new string. So the original string is not changed. And that's what I mean by immutable. There are a few special characters in C# that sometimes have different meanings. For example, if you want to have a new line in your string, you need to use \n. When the compiler sees that, it automatically adds a new line. If you don't add the backslash, the compiler sees n just as the letter n. Same for tab. If you want to have a tab, you use \t. Now that brings us to an interesting situation. What if you want to use the backslash letter itself? Because when the compiler sees backslash, it thinks we are using a special character. So it's not quite sure. It might get confused. So if we want to tell the compiler that we would like to use the backslash letter, we need to represent that by double backslash. Same for single quotation mark and double quotation mark. We need to prefix them with a backslash. And that's what we call by escaping characters in C#. So these are special characters. The list of special characters, in fact, is even more than that. But personally, I have not found any of those special characters that you find in C# documentation pragmatic. Those you see in this table are the ones I have found very common. Okay, now because of these special characters, there are cases where creating a string can be a little bit messy. For example, look at this path variable here. Note all these double backslashes we have. It looks a little bit messy, doesn't it? The good thing is, in C# we have a kind of a string which we call verbatim string. And with a verbatim string, we don't have to use all these double backslashes. We can simply prefix our string with an @ sign, and as a result, we can get rid of all these double backslashes and just use a single backslash. Okay, now let's flip over to Visual Studio and do some coding. Okay, let me start by creating a string called first name. So, string first name equals Mosh. Now, obviously, here we can use the var keyword because compiler knows we have assigned this variable to be a string literal, so that should be of type string. So we can make the code shorter. So I put the cursor here. I can manually change that to var, or with resharper, Alt and Enter, and Enter. Now let me show you something interesting here. Hover your mouse over the var keyword. Note that this variable is of type string, which is a class that is defined in the system namespace. In the lecture about primitive types, I explained that all primitive types in C# map to a type in the .NET framework. For example, let's use the int and declare a variable like number. If you hover your mouse on int, you see that's of type int32. And note that this int32 is a structure. So all these keywords we use in C# like int, char, string, float, bool, they all map to a type in the .NET framework. The primitive types are all structures, like this int or int32. But strings are classes. So let me remove this. Look at this one more time. So we have a class in the system namespace which is called string. What this means is you can create a string like this using the string keyword in C#, or you can use the string class in the .NET framework. The difference is when you use the string class, you need to import that namespace, the system namespace on the top, because here we're writing code inside this namespace, but we're accessing a class that is in a different namespace, the system namespace. So if you have resharper, you can automatically import that. Otherwise, you have to go on top of the file and type using system semicolon. So whether you use the string class like this example, or using the string keyword, it's exactly the same. There is no difference. And that's one of the things that confuses beginners to C#. Similarly, you can create an int32 using the int32 structure in .NET Framework. Call it I. Or you can use int keyword. They're essentially the same thing. Okay, now let's clean up all the extra noise here and get back to our example. I'm going to change this to var to make the code cleaner. So one way to create a string is to use concatenation. So we can declare another string and concatenate 3 strings together. But as I explained, sometimes it's hard to visualize the output, and we can use the string format method. So here is an example. So string again maps to the system.string class, and this class has a bunch of static methods, as you can see here. So these methods are accessible without the need to create an object. They're accessible directly on the string class. For example, you can use the compare method to compare strings. In this case, we're going to use the format method. So this method takes 2 arguments. The first one is a format string or a template, something like this. And the other arguments are values to supply to this template. So I'm going to pass first name and last name. At runtime, what we have here will be replaced by first name. Same, what we have in here will be replaced by last name. Now let's take a look at string.join. So I'm going to create an array of names. And I'm going to create a string by combining all these values using a comma as the separator. So we use the join method. Again, it's a static method on the string class. The first argument is a string, which represents a separator. We can use comma. And the second argument is the array. So names. Let's display the result on the console. So formatted names, just like that. So you see John, Jack, Mary. This is a very useful technique when you have some values and you would like to combine them together using a separator. Now let's take a look at verbatim strings. So I'm going to create a string that has multiple lines and has a few paths. So something like this. This string is very unreadable. So you see the output first, and then I'm going to show you how we can clean this up using a verbatim string. So instead of displaying formatted names, I'm going to display the text here. So this is the output. Hi John, then on a new line, look into the following paths. Then on two new lines, we have two paths here. As you see, using a normal string is very hard to format something like that. So we can use a verbatim string. All we do is we prefix it with an @ sign. Then we don't need \n. We can simply put that on a new line. Same here. Remove the \n on a new line. And we can remove all these double backslashes. So you see, it's much easier to read and understand this string. So whenever you need to use \, new line, or tab, use a verbatim string to properly format your string. So that was a quick introduction to strings to get you started. Later in this course, we have a separate section where I'll cover more details about working with strings. I hope you enjoyed this lecture, and thank you for watching. Okay, another type we're going to cover in this section is enums. An enum is a data type that represents a set of name-value pairs, or constants. Let me show you where you use enums in the real world. Imagine you're building an application for a post company, and you want to support a few different shipping methods. So one way is to declare a few constants, each representing a shipping method. And in your application, based on the shipping method, you can make decisions to calculate the shipping cost or the tax, or display different messages to the user, so possibilities are endless. Now, even though this approach works, it's a little bit messy. It's better to define a new type where we can represent different shipping methods. So that's where we use an enum. So we can create a new enum called shipping method with these three members. So in simple words, use enums where you have a number of related constants. Instead of declaring multiple constants, declare an enum. This will be a new type in your application, just like we have classes or structures. Okay, now that we have an enum, we can use it with the dot notation. Now, one thing I want you to know here is that an enum is internally an integer. But if you have a reason to change that and use a byte instead, perhaps it could be easier for you to map in your database columns, then you can specify byte during declaration of your enum. So that's the basic idea about enum. Now let's flip over to Visual Studio and let's see how to work with enums and how to convert them to numbers and strings. Okay, now I'm going to create a new enum called shipping method. Note that because enum is a new type, we need to define it at the namespace level. So now, if we don't set any values to the members of this enum, the first member is going to be automatically set to 0. And from there, every member's value will be incremented by 1. Now, in terms of best practices, I suggest always explicitly set values for these enums, because it's very likely that somewhere in your database, you might have a table that represents this enum. So you want to make sure the IDs or the values you assign to these enum members match to the records you have in the database. If you rely on the automatic value assignment, and sometime in the future add a new member to this enum, the value of some of the existing members may change and may no longer match the records in the database. So, okay, now we have a new enum, it's a new type, and we can use it when declaring a variable. So in the main method, and here we use the dot notation. Note that IntelliSense shows us all the members in this enum. So let's set it to express. Now I told you that internally an enum is an integer. So I can easily cast that to an integer if I want the numeric value of this enum. So let's display the numeric value of this shipping method on the console. So I put method here and then cast it to an integer. Let's run the application. So the value of express is 3. Now there are times that you receive a number from another system. It could be your database or it could be a third-party application supplying some data. And you need to convert that number, that integer, to a shipping method in your application. In situations like that, again, you can use casting to convert an integer to a shipping method. Let me show you what I mean. So imagine we received the number 3 from somewhere else. And we want to convert that to a shipping method. So we can use casting, shipping method, and put method ID here. Let's look at the result. So you see, the number 3 represents the express shipping method. So these are two examples to convert an enum to and from an integer. What about the strings? There are times that we need to convert an enum to a string, or get a string and convert it to an enum. Let's take a look at two more examples here. So I'm going to convert this method here to a string. So method dot, look at this method here. Every object in C# has a method called toString. So technically, you can convert anything to a string without doing any extra work. So all I have to do here is just to call the toString method. And when we run the application, we're going to see express on the console. There you go. Look at the third line. Okay, now as a tip, console.writeLine by default always calls the toString method on any value you pass to it. So in this example, even if I didn't call toString, console.writeLine would still convert that enum to a string. But in case you're not using console.writeLine and you want to explicitly convert that enum to a string, then you can use the toString method. So I'm going to revert this back. And final example. What if we have a string and we want to convert that to an enum? Again, the reason could be we have that string stored somewhere in the database or in another system. So something like this. We need to convert this method name to a shipping method enumeration. How do we do that? Well, before I show you that, I want to introduce you to a new term, parsing. Parsing in programming means getting a string and converting that to a different type. So we say we parse the string, which means we convert that string to a different type. So technically here, I want to parse this string into a shipping method. How do we do that? Well, we have a class in .NET called enum. This class is defined in the system namespace. So if you don't have using system on the top of your file, you need to add that here. Now this class has a number of static members. So if you put dot here, we can see it's static methods. And look, here we have a method called parse. Let's look at the parameters of this method. So open the parentheses again. So this method has two versions, which we call two overloads. The first one takes two parameters. The second one takes three parameters. Let's take a look at the simpler one. So the first parameter is a type object. What is a type? Type is a class in .NET that represents metadata about other types. As a pragmatic tip, whenever you see the type object, you can use the type of operator. So look, type of, this is a keyword, this is an operator, and takes a parameter. So here we need to specify the target type that we want to convert this string to. What is the target type here? Our shipping method. So shipping method here. Now look at the second parameter of this method, string value. So here I pass method name. Now look at the return type of this method. It returns an object. It does not return a shipping method. So we need to cast this object to a shipping method, which means I go to the beginning of the line, use cast here, shipping method. And now I can store the result of this expression into a different variable. Let's call it shipping method. I forgot the semicolon. There you go. Now, if I hover my mouse over var, look, the type of our variable is a shipping method. So this is how you convert or parse a string to an enum or enumeration. Okay, so far we have talked about various data types in C#. We looked at primitive types like integer, character, float, bool, and a few non-primitive types like classes, structures, arrays, and strings. And I told you earlier that both strings and arrays are classes. So I showed you during one of the demos that the string keyword maps to the string class in .NET. And same goes for the array notation that maps to the array class. Now, that brings us to an interesting topic. In C#, essentially we have two main types from which we create new types. We have classes on one side and structures on the other side. So every type you have learned so far is either a class or a structure. So all primitive types are structures. Remember I told you use structures for small types like RGB color and point. Well, all primitive types are very small types. They take no more than 8 bytes. That's why they are internally defined as a structure in .NET. Arrays and strings are both classes. We can also create custom classes like person or calculator. Now, in C#, these classes and structures are treated differently at runtime in terms of memory management. And that's what I'm going to cover in this lecture. I want you to understand what happens under the hood in memory, so if your program does not behave the way you expect, you'll be able to troubleshoot it. Structures are what we call value types, while classes are reference types. When you create a variable that is a value type, a part of memory called stack is allocated for that variable. This memory allocation is done automatically, so you don't have to worry about it. When this variable goes out of scope, it will immediately get removed from the stack by runtime or CLR. With reference types, however, you, the programmer, need to allocate memory yourself. Remember the new operator? We use the new operator with classes. So when we use the new operator, we tell the runtime to allocate memory to this object. And this happens from a different area of the memory called heap. This memory, unlike stack, is more sustainable. So if you create an object and that object goes out of scope, it will continue to exist in the heap for a little while. It won't be removed immediately. There's a process called garbage collection, which is done by runtime or CLR that takes care of this. So once in a while, CLR looks at the objects that are no longer used and removes them from the heap. Now, this was the theory behind value types and reference types. What you need to know in pragmatic terms is when you copy an object to a new variable, depending on whether that object is a value type or a reference type, there will be two different outcomes. And it's much easier to show this in code. So let's flip over to Visual Studio and see how copying value types and reference types are different. Okay, in this video, I'm going to show you reference types and value types in action. I'm going to use two different examples. So I'm going to start with a simpler one. First, I'm going to create an integer variable. So a is 10. Now I'm going to create another variable called b and copy a to b. And finally, I'm going to increment b by 1. So I'm going to use the increment operator. Now I got a question for you. What do you think the value of a is going to be at this point? Is it going to be 10 or 11? The answer is 10. Because integers are value types. So when we copy a value type to another variable, a copy of that value is taken and stored in the target location in memory. So let's verify this. I'm going to use console.writeLine. And here I'm going to display a and b on the console. What is a good way to display a and b? We can use string format. Remember string format? So string.format. Here we supply a format string. So 0 and 1 here are placeholders. And now we supply arguments to fill these placeholders. So A and B here. Now let's run the application with Control and F5. So look, A is 10 and B is 11. So the lesson is, when you copy a value type to a different variable, a copy of that value is taken and stored in the target variable. That's why we call them value types. Their values are copied. Let me show you what just happened in memory. So imagine here is the stack, and somewhere in the stack we have a location identified by A, and in that location we have the value 10. When we copy A to B, a new location in memory in stack is created, identified as B, and the value we had there in A is copied to B. That's why these two variables are now completely independent, and making a change to one does not impact the other. Now let's see reference types in action. So this time I'm going to create an integer array. And as you know, in C#, an array is a class. So it's a reference type. So let's create array1. And here I'm using the object initialization syntax to initialize my array with 1, 2, 3. Now I copy this array1 into another variable called array2. And finally, I'm going to make a modification to array2. So let's say I want to set the first element to 0. At this point, what do you think is going to be the first element of array1? Is it going to be 1 or 0? It's going to be 0. Let's go back to the memory visualization again and see what happens when we run this code. So here we've got stack and heap. When we create and initialize array1, this is what's going to happen. First, an object is going to be created on the heap. This object is in a memory location with the address you see here. And inside this memory location, we have the actual array with 3 elements, 1, 2, 3. Next, the runtime or CLR creates a variable on the stack identified as array1. The value inside this variable or inside this memory location is a memory address. And that's the address of the object on the heap, the actual array. So array1 points or references the object on the heap. So this is what happens when we create and initialize array1. Now let's see what happens when we copy array1 to array2. So the runtime creates another variable on the stack identified as array2. And again, inside this variable, we're going to have a memory address. And as you see in this picture, this address is the address of the object on the heap. That's why both array1 and array2 point to the same object, which means when we make any changes on this object on the heap, either through array1 reference or array2, the changes are visible through the other variable. That's why we call these types reference types. So when we copy them, their reference or their memory address is copied, not the actual value. So back to the code, let's verify this. Again, I'm going to use console.writeLine and string.format. So I display the first element of both array1 and array2, and they both should be 0. Let's run the application. They both are 0. Okay, let's take a look at another example of reference types and value types in action. So in this code, I have defined a class called person with one field called age. And inside our program class, I have defined two methods, increment and makeOld. The return type of both these methods is void, which means they don't return any values. And the reason I have defined both these methods as static is simply to call them without the need to create an object. Just want to keep things simple. So in the main, first I'm going to create an integer called number. And I set it to 1. Now I'm going to call the increment method and pass my number variable as an argument. So the increment method takes a parameter of type integer called number and adds 10 to it. Note that here I'm using the addition assignment operator to add 10 to the number that is passed to this method. Now, at this point, what do you think is going to be the value of our number in the main method? It's going to be 1, because this is a value type, and when we pass this variable as an argument to the increment method, a copy of this variable is taken and sent to the increment method. So interestingly, even though these two variables have the same name, but they are in two different locations in memory. One is the number with the scope of the main method. So outside the main method, this variable does not have a meaning. And here we have another number, coincidentally have the same name, inside the increment method, but that's a different place in memory, and its scope is limited to the increment method. So when this increment method is called, that new location is created called number, its value is incremented by 10, and then it's immediately destroyed. Now let's verify this. So I'm going to use console.writeLine and display number. We run the application. So our number is 1. It's not affected by the increment method. Now let's take a look at an example of a reference type. So this time I'm going to use our person class. So I create a person object and use the object initialization syntax to set its field. So this person is 20 years old. Now here we have another method called makeOld that takes a person object and adds 10 to its age field. So note that here, because the type of this parameter is a reference type, the object that is going to be passed here is not going to be copied. Its reference is going to be copied, which means both the person object we have in the main method and the person object that we have as a parameter to this method will be pointing to the same object on the heap. Okay, so if I call makeOld and pass this person object, upon returning from this method, the age of this person is going to be 30. Let's verify that. So person.age. And let's run the application. There you go. That's it for this lecture. I hope you enjoyed it, and thank you for watching.
So in this section, you learned that we have two main categories of types in C#. On one side, we've got classes. On the other side, we've got structures. Examples of classes are strings, arrays, or any custom classes that you create. Examples of structures are all the primitive types like integer, character, float, and any custom structures that you create. The difference between the two types is purely memory management, and you can review that again in the lecture called Reference Types versus Value Types. Now, from the next section, things start to get really interesting, because I'm going to teach you about control flow, and you'll be able to write simple C# programs. And then in each section, you will learn something new about C#, and you'll be able to write more interesting programs. So I will see you in the next section. In this section, we're going to explore conditional and iteration statements in C#. We use these statements to control the flow of programs. So from this section, you're going to start writing simple C# programs. Now, I have designed a number of programming exercises that you can find at the end of this section. Whether you're new to programming or been programming for a while, I highly recommend you to spend half an hour, if not more, going through these exercises. Because not only will they help you remember the language syntax, they will also train your programming brain, which is absolutely crucial if you want to be a successful programmer. So go through the lectures and spend some time doing the exercises. Now, whether you solve the problem or get stuck, I think it's still a good idea to look at my solutions as a different way of solving the same problem. By the way, my solutions are by no means perfect. In fact, there is no such a thing as perfect in programming. You give a problem to 10 different developers and each come with a different solution. So do your best to solve the problem and look at my solutions for inspiration. Now let's get started.
Okay, we got to conditional statements. In this lecture, we're going to talk about the language constructs of C# that are used for controlling the program execution. In C#, we have two types of conditional statements. We have if and else, and we have switch and case. We also have a conditional operator, which is basically a short way of writing an if and else. Let's take a closer look at each of these statements. Here's the basic structure of if statements. With if, we always have a condition, which is enclosed in parentheses, followed by a statement that will be executed if the condition is true. We can optionally have an else if with another condition, and again another statement that will be executed if the condition is true. And optionally, we can have an else statement. So if none of the earlier conditions is true, then this piece of code will be executed. If we have more than one line of code after if or else statements, we always need to enclose them with curly braces. We can also use that if we have only one line of code. We can also nest if statements inside each other. So here, as you see, I have got an if statement, and inside its body, I've got another if and else statement. Now, one thing I want to warn you is to avoid using multiple nested if statements. Multiple nested if statements result in code that is hard to read, hard to understand, hard to maintain, and hard to test. So that's what we call a code smell, and that's something you should avoid at all times. Switch is slightly different from if. With if, we usually have a condition that is evaluated, and if it's true, then some piece of code will be executed. With switch, however, we have a variable, and we compare the value of that variable with different values. So in this case, I have a switch on a variable here called roll, which is an enumeration. I have two case statements here. At least we should always have one, but you can have more depending on your circumstances. So I'm comparing the value of roll with this one here, roll.admin. So if the roll is admin, then this piece of code will be executed. And note that each case statement is terminated by a break statement. Then I have another case statement. So if the role is moderator, then this piece of code will be executed. If none of these conditions is true, then the default block will be executed. And of course, we need to have a break statement here as well. Now let's jump into code and explore each of these constructs in action. Okay, first I start by defining a variable and call it hour and set it to 10. My intention is to define hour as a 24-hour time format. Now I can say if hour is greater than 0 and it's less than 12, console write line it's morning. So as you see, I put the expression here. That is a Boolean expression. I'm using AND here. So these two conditions will be evaluated, and if both are true, then this will be executed. Now I can have another condition. So I write else if hour is greater than or equal to 12 and it's less than 18, which is 6 p.m. console write line afternoon. And finally, I can have an else statement. So if none of the earlier conditions is true, then this piece of code will be executed. So it's evening. As I told you, if you have more than one line of code, you need to enclose them in curly braces. But some people say even if you have one line of code, it's good practice to put them in curly braces like this. Similar here. There you go. Let's run this program using Control and F5. So it's morning. In this case, because the hour was 10, this condition was evaluated and it was true, so this piece of code was executed. Now let's take a look at conditional operator. I'm going to change this piece of code. So first, let me clean this up. With ReSharper, we use Control and W to select some piece of code like this. It's really easy. It's much easier than putting the cursor here and using Shift and down arrow like that. So anywhere you are in the code, you can use Control W to select a piece of code or keep extending your selection like this. Okay. Now let's take a look at conditional operator. So I can define a bool, say is gold customer, and set it to true. I want to say if is gold customer, I want to have a float here, call it price. And here I say price is going to be $19.95. Otherwise, price is going to be $29.95. Now I can rewrite this code using a conditional operator. So I would say float price equals, I'll put the condition here, is gold customer, followed by question mark. Now if that condition is true, what do I want? I want $19.95. Else is specified using a colon. The price is going to be $29.95. And of course I can get rid of this. I just comment it. I keep it here so you can see them for comparison. And finally, I'll put the price on the console. So let's review one more time. That's the condition. If that's true, then what we have after question mark and before the colon will be executed. So $19.95 will be returned and assigned to the price variable. Otherwise, is specified using a colon. And here, what we put here will be returned and set to the price here. So it's just a shortcut to write an if-else statement. Let's run the application. So the price is $19 because I'm a gold customer. Now let's take a look at switch case. So with ReSharper, I use Control and W to select everything here and clean it up. So actually, let me define an enumeration first. Public, enum, season. So we have 4 seasons: spring, summer, autumn, and winter. In this case, we don't really need to give an explicit value to each of these items here because we are not working with a database or an external application where there is a numerical representation for these seasons. So we just leave it like that. And to keep my code clean, I would like to put this in a separate file. So with ReSharper, what I can do is I put the cursor here. And as you see, I've got this marker here. So with Alt and Enter, I can activate that and press Enter and move it to another file. If you don't have ReSharper, what you need to do is to go to Solution Explorer here right-click your project, go to Add, New Item, and here you select Class to add a new class. Let's call it Season 2 because I already have a file called season.cs. So I'll put that new class here. Now I'm using an enumeration, not a class. So I can get rid of this. And then I can just go here and copy this piece of code and put it into this file here. So as you see, it's much easier and faster to use ReSharper. All right, I'm just going to get rid of this file and delete it here. Okay, so we defined an enumeration called season with 4 values here. Now let's go to program. I'm going to define a variable. This time I'm going to use var, call it season, set it to season.autumn. Now let's put a switch on season. Switch season. So we put the variable in parentheses. Here we have a block, and we can have one or more case statements. I can say if season is season.autumn, display on the console, it's autumn and a beautiful season. I terminate this case block with a break statement. Now I can have another case statement here. If season is summer, console.writeLine, say, it's perfect time to go to beach. And break. Finally, I can have a default here. So if the season is none of these values, I can say, I don't understand that season. It's a little bit stupid, but that's just for demonstration. And of course, we need a break statement here. Let's run this application now. So it says it's autumn and a beautiful season. Now let me show you something. Let's say in autumn and summer, we would like to have a promotion. So instead of displaying this message here, we would like to say something like, we've got promotion. And I would like to have the exact same message appear if the season is summer. Now, as you see, this piece of code looks like a duplicate. It's not a good thing. What we can do here is to get rid of these statements here and have these two case statements next to each other. Note that the first one got nothing next to it, and the second one has the actual code that will be executed. So in this case, what that means is if the season is autumn or summer, then this piece of code will be executed. Let's run the application. We've got promotion. That's it for this video. I hope you enjoyed it, and thank you for watching. Okay, we got to iteration statements. If you have done programming before, you know that pretty much every programming language has a set of iteration statements which are used for repeatedly executing a sequence of statements. In C# we have 4 iteration statements: for each, while, and do while. So let's examine the syntax for each of these iteration statements. For loops have 3 parts. Here's the first part, semicolon, second part, semicolon, and the third part. The first part is what we call the initialization clause, and that's where we create a counter for controlling the number of times the loop will be executed. So here I have created a counter called I and set it to 0. You're free to use any names for your counter variables, but I is a common convention. The second part is what we call the condition clause. So the for loop here will be executed as long as this condition is valid. And the third part is what we call the iteration clause. And here we typically increment or decrement the counter variable. So here, because I set I to 0, I would increment I in every iteration until it reaches 10. And inside the body of the for block, we have a sequence of statements that will execute repeatedly. For each is used to iterate over elements of an enumerable object. What do I mean by enumerable? In simple words, that means anything that has some kind of list or array nature. So far, you have learned about arrays and strings. A string, as you know, is a sequence of characters. So a string is enumerable. The array type is also enumerable. So anything that has some kind of list nature is enumerable, and we can use for each to iterate over their elements. We can definitely do the same thing with a for loop, but doing that with for each is easier and cleaner. In terms of syntax, here is what a for each block looks like. We have a local or temporary variable, in this case I call it number, and here we have the in keyword, and here is the list or object that we are iterating. So assuming that numbers is an array of integers, in every iteration, number will hold the value in the current element of the array. In C# we also have while loops. In terms of syntax, a while loop includes a condition here in parentheses. As long as this condition is valid, the loop will execute. Typically, we have a counter that we initialize before the while loop is executed, and at the end of the while loop, we increment it. So as you see, it's kind of similar to for loop, but it has a different syntax. Whether you use for or while loop, it's up to you. It's kind of personal preference. And finally, we have do while loops. Do while is slightly different from while loop. With do while loop, the loop is executed at least once, because the condition is evaluated at the end of the loop. So here we have do, a block of statements that will execute. We have our counter, which we increment or decrement, and eventually is the condition. Now you don't always need a counter with while and do while loops. You can use any condition. In the slides here, I used a counter called I to demonstrate that the same thing can be implemented with a for, with a while, or with a do while loop. And finally, before we start coding, let me show you two more statements here. We have break and continue. So in any loops, we can use break to jump out of the loop or continue to jump to the next iteration. Now let's start coding and see what all of this means in action. Okay, imagine we want to display the list of even numbers from 1 to 10. So we need the loop to go over the list of numbers between 1 to 10, and for each number, we need to check the remainder of its division by 2, and if it's 0, that means it's an even number. So let's start with a for loop. So with this loop, we set I to 1, and as long as I is less than or equal to 10, in each iteration, we increment I by 1. Now we need to check the remainder of division of I by 2. So if that's 0, we want to display I on the console. Just that. Let's run the application. So we got 2, 4, 6, 8, and 10. Now what if we want to reverse this order? Let's try this program again. So this time, I'm going to create another for loop, but instead of starting from 1, I start from 10. And I change the condition to, as long as I is greater than or equal to 1, then I minus minus, which means decrement I by 1. Now we're going to have the same condition. Console the right line, I. So let's run the application again. Okay, now you see in the second part, we start from 10 and then we have 8, 6, 4, and 2. Okay, now let's take a look at the for each loop. But before we start with that, let me write a simple program with for loop, and then I'm going to show you how for each makes that program cleaner and easier to understand. So let's imagine we have a string called name. So var name equals, we set it to John Smith. So a string, as you know, is a sequence of characters. It's an enumerable object. It's like a list. So we can iterate over that. So now I want to iterate over this string, and I want to display each character on a new line. So I start with a for loop. So let's see what's happening here. This time I'm setting my counter variable or I to 0 because the index of the first character in a string is 0. And I'm going to increment I one at a time as long as I is less than the length of name. So as you see here, each string, like name, has a property called length, which returns the length of that string. Okay, now let's display each character on a new line. So console.writeLine, name of I. Pretty simple, right? Let's run the application. So that's the output I was talking about. Now let's see how we can rewrite the same code using a for each loop. So with for each, I don't have to worry about a counter variable like I. I don't have to set it to an initial value like 0. I don't have to compare it against some other value like name.length, and I don't have to increment it. So instead, we have a variable here called character, which in each step of the iteration holds one character of the string. Also interestingly, note that in the console.writeLine, we can simply display character instead of accessing the character at the given index in the name variable. Okay, now let me comment out our for loop. So with Control K and Control C. Now let's run the application. We got the exact same output. So whenever we have an enumerable object, like a string or an array or any kind of list, it's much easier to iterate over them using a for each. Let's change this example and iterate over an array. So I'm going to clean up everything here. Now I'm going to define an array of numbers, var numbers. And I'm going to use object initialization syntax to initialize that array with some numbers. So that looks like this. 1, 2, 3, 4. So with arrays, as you see, we have to instantiate them using the new operator. Okay, now let's iterate over this array. For each, var number in numbers, console.writeLine number. Let's run the application. So as you see, for each is an easier way to iterate over a list. Okay, earlier we wrote this simple program to display the list of even numbers between 1 to 10 using a for loop. And I told you during the slides that you can write the same code with for, while, or do while loop. So now I'm going to write the same program using a while loop. Okay, before we get started, I want to comment out this code. Okay, first let's declare a counter variable. So I is 0. While I is less than or equal to 10. Now our condition. We display I on the console if it's an even number. And here we need to increment I by 1. So this is the exact same code, but written using a while loop. Now in this case, I prefer to use a for loop for this scenario, because typically we use the for loop when we know the number of times we would like to do an iteration. So it's cleaner to declare that counter variable like I when we are declaring the for block, as opposed to outside the while loop as we have here. Okay, now you might be wondering, when do we use the while loop? Well, there is no hard and fast rule, but typically it's better to use a while loop when you don't know ahead of time how many times you're going to do an iteration. Let me show you an example here. So first, let me clean up this code. We want to write a simple echo program. In this program, we're going to display a message on the console asking the user to type their name. If the user types their name, the console is going to repeat or echo that name. But if the user simply presses enter without typing a name, the program is going to terminate. So in this case, we don't know ahead of time how many times the user is going to use the program. how many times are we going to echo? In that case, it's better to use a while loop. So how do we do that? So in this case, we're not going to have a counter variable. So instead, what I'm going to do, I'm declaring a while, and in the condition, I'm just going to use true, which means this loop is going to execute forever. Let me display a simple message on the console. So console.write. This time I'm going to use the write method instead of write line. The difference is the cursor is going to be on the same line. We're not going to have a line break. So type your name. Let me run this program and see what happens. So you see this program is executing forever because that while loop is not terminating, and the program keeps displaying type your name. So let me terminate this. So at this point, we need to read something from the console. So we use console.readLine method. And this method, take a look at its signature. So I remove the parentheses, I open it again, look at the tooltip. This method returns a string. So we can store the result in a string, call it input. Now, if the user simply presses enter and do not type a name, that input is going to be an empty string. And if that's the case, it's the time to jump out of the loop. So, to check if a string is empty, we often use string.isNull or white space method. This method expects a string and returns a Boolean value. So if input is null or white space, then this condition is true, and then at this point, we're going to break. And with break, we jump out of a loop. Otherwise, if that does not happen, we want to echo the name. So console.writeLine, echo, and now we're going to append the input here. Let's run this application. So type your name, Mosh, echo Mosh. Note that the program continues execution. So this time I type John, and it echoes John. Now this time I'm going to press enter, and the program terminated. One of the questions beginners ask me is, how does this press any key to continue appear here? I didn't write any code for that. When you run your application using Control and F5, by default, when the application terminates, the console displays that message for you. Okay, now I'm going to change this program a little bit so we can learn about the continue keyword. So what I'm going to do here is I'm going to apply a not operator here. So if the input is not null or white space, in that case, we want to echo it, right? So let's not worry about this break. I'm going to move this console.writeLine here. Now I'm going to put that break here. So what do you think is going to happen now? When we run the application, first we get this message, type your name. We type a name. Of course, it's not null or white space. We're going to get an echo, but then we get to this statement, and that causes the loop to terminate. So this program is going to execute only once. How can we change this so it can behave like before? That's when we use the continue keyword. So I'm going to put the continue here, and let me explain what happens. So at this point, after we echo the name, when the program sees this continue, instead of continuing here, it's going to continue to the beginning of the loop. So we get back here, and the condition is true. So the loop continues to execute. Let's run the program. Type your name, Mosh. The loop is continuing. Type your name, John. Now this time just press enter and the loop terminates. So as you saw, we can write the same program in different ways. Sometimes you may apply a not operator, and because of that you may have to use the break or continue. Which one is right, which one is wrong? There is really no right or wrong. You need to do your own judgment. Which code is more readable and more understandable? In this video, I'm going to show you a useful class to know in .NET Framework, which is called random. We use this class to generate random numbers. So first we create an instance of the random class. This class has a few useful methods. Next, which returns a random integer. Next bytes, which takes a byte array and fills it with some random numbers. So you can create a byte array of any size, pass it to this method, and this method will fill that byte array with some random numbers. And next double, which returns a random double between 0 and 1. Let's take a look at the next method. This method has 3 overloads, as you see on the screen. The first one takes no parameters, and it simply returns a non-negative random number. So let's create a for loop and generate a few random numbers and display them on the console. Okay, let's run the application. So you see some random numbers here. Now, there is something interesting we can do with the next method. Let's take a look at this method again. The second overload takes a maximum value, and the third overload takes a min and max value. This is very useful when we want to limit the range of random numbers. So if you want to create random numbers between 1 and 10, we simply supply them here. Let's run the application again. So now we have random numbers between 1 and 10. We can use this technique to even generate random characters, like random passwords. Each character internally is represented using a number, because computers don't understand characters and letters. They understand numbers. Let me show you what I mean by that. So I temporarily comment this out. And all I want to do is display character A on the console, but I want to cast it to an integer. We got 97. So 97 is the standard number to represent a lowercase a in a computer. This was first introduced as ASCII, which stands for American Standard Code for International Interchange. Let's take a look at this website, ASCII-code.com. So in this table, you can see the letters, like, let me show you here, like plus, all these numbers are alphabets A, uppercase A to Z, lowercase. See, all these characters have a number represented in decimal format, which is here, and they also have a binary representation. This is eventually what a computer understands. Now, if you look at 97, you see a lowercase a. And let's take a look at the Z. So Z is 122. So what this means is if you generate a random number between 97 and 122, and then cast it to a character, we'll get a random character. And we can repeat this a few times and generate a random string, like a password. Let's give it a try. So let's bring this back in. What I want to change here is limit the range to 97 and 122. Now, if we run this application, we're going to get a number coming from the next method. So we need to cast it to a character. And I'm going to change right line to right because I don't want each character to be on a new line. Let's run the application. This press any key to continue message is messing up with us. So let me add a console.writeLine here so you can see more clearly. There you go. So here's a random string. Now, a tiny problem with this code is if someone look at this code, they have no idea what is 97 and 122. So let me show you a more expressive way to write the same code. What we can do is replace that with 0 and 26, because we have 26 characters in the English alphabet. Now, we get a number between 0 and 26 if we add that number to character A, what do you think is going to happen? Well, this is a character, and internally it is represented as a number. And when we add this character to a number, the result is going to be a number. Then we cast it to a character, so eventually we get the same result, a random character. Now, in the real world, we don't want to create a random string and display it on the console. Most likely, we would like to store it in a string. But there is a tiny problem here. In the last section, I told you that strings are immutable, which means once you create them, you cannot change them. Of course, there are methods that you can apply on a string and you get an updated value. But in every case, the original string is not affected. You always get a new string. So in C#, we cannot create a string and set its individual characters using a random character. But what we can do instead is to store this result in an array and then create our string based on that array. Let me show you how it works. So first, I declare a character array. Let's call it buffer. And because we are generating 10 random characters here, I'm going to set the size of this array to 10. And of course, we can use var here. As you see, the green highlight is indicating that. The code is cleaner. Now, instead of displaying each character on the console, we can simply store it in the buffer. So let's get rid of this console.write and store it in the buffer. So I'm using I, the loop counter variable, to access an element in the buffer array. Now the last step is to create a string based on that character array. Now most of the time we create a string like this. So we use a string literal. But there is a less common way to create a string in C#. It's not something that you use every day, but it's good to know that as something in your toolbox. So we use the new operator. If you remember from last section, the string keyword maps to a string class in the .NET framework. And you know that with classes, you can create an instance of them using the new operator. So we can do new string. And look, here in the constructor of a string, we have a few overloads. The last one, as you see here, takes a character array. So if we pass our buffer here, we will get a string based on that character array. Now we can display this password, which is a string, on the console. Look, we got the same result. One last thing I would like to add here to improve the quality of this tiny little code, and that is, I don't like these magic numbers here, 10 here and 10 here. The problem with this is, if tomorrow we decide to change the length of our random password, we have to come here and change this 10 to 8, and we have to remember to do this here as well. So a better way is to declare a constant like password length, set it to 10. We can use that to create our array, and of course use it in the for loop. The code is more expressive and more reliable. So that's all you need to know about random class. I hope you enjoyed this lecture, and thank you for watching.
So in this section, you learned about conditional and iteration statements in C#. I hope you spent some time doing your exercises. If you have been programming for a while, don't say, "No, Moshe, I have done this a million times before, it's too easy for me." Trust me, these exercises help you become a better programmer. And that's what we're going to do from this section onwards. So in every section, again, you're going to see a number of programming exercises, and they gradually get more challenging. So do your exercises, and I will see you in the next section. Okay, at this point, you know a little bit about arrays. In this section, I'm going to expand your knowledge about arrays and introduce you to multi-dimensional arrays. This is useful if you're working with structures such as a matrix. I'm also going to talk about generic lists, which are very useful in building real-world applications. Again, similar to the last section, I have designed some exercises to help you train your programming brain. So be sure to go through the lectures and spend half an hour doing your exercises. Now, let's get started.
Earlier in this course, we learned a little bit about arrays. In this lecture, we're going to take a deeper look at arrays. So first, I'm going to have a quick review of arrays. Then I'm going to talk about different types of arrays we have in C#. And finally, I'm going to introduce some useful methods to work with arrays. So just to refresh your mind, an array represents a fixed number of variables of a particular type. In C# we have two types of arrays, single-dimension arrays and multi-dimension arrays, like a matrix. So single-dimension arrays is what you have seen before. In this example, we have an array of integers called numbers, and the length of this array is 5. If we know ahead of time the values we would like to store in an array, we can use the object initialization syntax to initialize that array upon declaration. So nothing new so far. Now let's take a look at the types of multi-dimension arrays. We have two types of multi-dimension arrays in C#, rectangular and jagged arrays. So with a rectangular array, each row has the exact same number of columns. So in the example you see in this slide, we have an array of 3 rows and each row has 5 columns. With a jagged array, however, the number of columns in each row can be different. A different way to look at jagged array is an array of arrays. So you can think of the jagged array we have in this slide as a single dimension array with 3 elements, and each element is another single dimension array. Now, what's the difference? When do we use a rectangular array or a jagged array? In .NET, CLR is optimized around single dimension arrays. So let's say you want to model a matrix. It's faster to implement it using a jagged array than a rectangular array. Having said that, the difference might be really tiny, especially with the computers we have these days. So my pragmatic advice to you is don't get stuck about the difference between rectangular and jagged array too much. Just be aware that in C# we have two types of multi-dimension arrays. Now let's see how we can declare a rectangular array. So here is the syntax for declaring a two-dimensional rectangular array. So the only new thing you see here is that in the square brackets, we need to specify the dimensions of the array. So in this case, this array has 3 rows and each row has 5 columns. If we know the values we would like to store in this array ahead of time, we can initialize this array using object initialization syntax. And if you want to access an element in this array, just like before, we use the square brackets, but we need to supply the index of the row and the column. If we want to declare a 3-dimensional array, we can extend the previous example and supply 3 dimensions while declaring the array. So in this example, our colors array has 3 dimensions. Now let's take a look at the jagged array. So imagine we want to model an array that looks like this. So as I explained earlier, you can think of this array as array of arrays. So at the top level, we have a single dimension array of 3 elements. In each element, we have another single dimension array. So in our first element, we have an array of 4 elements. In the second element, we have an array of 5 elements. So how do we implement this? Well, first we need to declare a top-level array. Note the syntax here. We use 2 square brackets to represent a jagged array. In the first square brackets, you specify the number of elements in your top-level array. Now we need to initialize each element of this array to a different array. So we are specifying that the first element of this array is another integer array of size 4. And to access an element in this array, again, we need 2 square brackets. So the difference between the jagged array and rectangular array from a syntactical point of view is that with jagged array, we have 2 square brackets, whereas with rectangular array, we have 1 square bracket, but we separate the dimensions using a comma. In C#, all arrays map to the array type that is defined in the system namespace of .NET Framework. So the array type is a class. It has a bunch of properties and methods as you see in this slide. Okay, now let's flip over to Visual Studio and see all these concepts in action. So in this video, we're going to take a look at some of the useful properties and methods of arrays. Let me start by creating an array of integers and call it numbers. So int array numbers equals new int array. And I'm going to use the object initialization syntax to immediately initialize this array. So some random numbers here, like 3. Now note this green underline here. ReSharper is suggesting to use var to make the code cleaner. So I'll put the cursor here, Alt and Enter, and Enter. Also here, note that int is grayed out, which means it's not necessary. So we can keep the code even shorter. So again, Alt and Enter, and Enter. Now, let's take a look at the length property. Length returns the size of the array. So in this case, we have 6 elements in the array, so the size of the array is 6. So console.writeLine. Let's run the application. So we got 6 on the console. Now let's take a look at the index of method. We use this method to find the position of an element in the array. Let's say we are looking for 9. So we can use this method like this. Array.index of, I open the bracket. Look at the tooltip. There are different ways to call this method, and that's what we call method overloading. So in this example, this method has 5 overloads, or 5 versions. I'm going to use the first one, which is the easiest. So look at the first parameter. That's the array that we're going to do a search in. The second parameter is the actual object we're looking for. So I press escape, pass my numbers array here, and as the second argument, I'm going to pass 9. This method returns an integer. So I'm going to store the result in a variable called index. Let's display index on the console. So the index of 9 is 2, which means it's the third element in the array, because in C#, the index of the first element in an array is 0. Now let's take a look at the clear method. So this method has 3 parameters. The first element is the array. So I pass numbers here. The second parameter called index is the starting index of the range of elements to clear. Let's say we would like to clear the first 2 items. So I'm going to pass 0 here as the starting index. And the third parameter is the length, which is the number of elements we would like to clear. So I'm going to pass 2 here. Now I'm going to iterate over this array using a for each block and display all the elements. So let's take a look at the effect of clear method. Note that the first 2 items are set to 0, and that's the meaning of clear. So in this example, because our array is of type integer, clearing these numbers means setting them to 0. If we have an array of booleans, clearing that array means setting some of its items to false. And if we have an array of strings or other kind of objects, clearing the items in that array means setting them to null. Okay, now let's take a look at the copy method. So this method takes 3 parameters. The first parameter is the source array, the second parameter is the destination, and the third parameter is the number of elements we would like to copy. So before using this method, I need to declare another array. So this is a smaller array. It has only 3 elements. So I'm going to copy the first 3 numbers from our numbers array into our another array. So and now let's display the result on the console. And run the application. So notice that after we call the copy method, the first three elements in the numbers array, which were here, are copied to the second array. Now let's take a look at the sort method. This method, again, has 5 different versions. I'm going to use the first one, which is the easiest. So I simply pass our another array. Let's display the result on the console. And run the application. Actually, this was not a good example because our second array was already sorted. So I'm going to apply the sort method on our original array. So, and we need to change that in the for each block. Let's run the application again. That's better. So we got 0, 0, 2, 6, 9, and 14. And one more method we need to explore in this lecture is the reverse method. Okay, let's run the application. So here's the effect of the reverse method. Okay, before we finish this lecture, there are a couple of things I need to point out here. The first one is, look at the first example. We access the length property on the numbers object. Whereas in other examples, all the methods we called, like index of, was called on the array class itself, not the numbers object. So what is the difference? The difference is if a method is accessible on the class itself, like array, that means it's a static method. We're going to take a look at the static members later in this course. For now, just remember, when a class member, like a method or field or property, is declared as a static, that means it's accessible from the class itself. But otherwise, that member is accessible via the object. So let me show you an example here. If I type array dot, these are all the static methods defined in the array class. But if I type numbers dot, these are the members that are not static. They are instance members, which means they're accessible via an object. So if I type index of here, you see, there is no method called index of. Or if I type clear, there's no such a method called clear. That's why it's only accessible from the array class. Now you might be wondering, how did I know which member is static and which member is not? Well, part of that is the experience. But if you try to access a member and you cannot find it, your best help is Google. Simply go to Google, and let's say we are looking for the sort method of the array class. We simply type C# array sort. And the first method, pretty much in every single case, is the documentation on the MSDN, Microsoft Developer Network. So if we go here, this is the standard documentation of the sort method of the array class in .NET Framework. So you can see all different ways of calling this method. That's what we call overloading. Remember? So a method can have different overloads, which means it has different versions. So note that all these methods have a red S in front of them. That means it's a static method. Now let me show you the array class itself. So we scroll down, we go to array class. I note that these properties here, they don't have that red S, which means they're not static. They're instance members. They're instance properties. And look, most of these methods, except clone and copy to here are static. So whenever you get stuck, just jump on Google, type C# and then type the name of the class and the name of the method. I hope you enjoyed this lecture and thank you for watching. In the last lecture, you learned about arrays. You learned that in C# arrays have a fixed size, which means once you create them, the size cannot be changed. But there are situations where you need to work with a number of objects, but you're not sure ahead of time how many of those objects you're going to work with. That's where we use a list. A list in C# is similar to an array in the sense that it's a data structure for storing a number of objects of the same type. But we use a list when we don't know ahead of time how many objects we're going to store in that list. To create a list, we use the list type. List is a generic type, and that's indicated by the angle brackets as you see in this example. Inside the angle brackets, we specify a generic parameter, and that parameter specifies the type of the list. So in this case, I'm creating a list of integers. You can create a list of anything. You can create a list of strings, or a list of characters, or a list of any non-primitive types. You can create a class called product and create a list of products. Generics is an advanced topic, and for now, that's enough for you to know that when you're working with a generic type, you need to specify generic parameters inside the angle brackets. In the third part of this course, C# Advanced, I'm going to cover generics in more detail. If you know ahead of time the objects you would like to store in the list, you can initialize your list using the object initialization syntax as you see here. So you put the objects between curly braces during initialization of your list. And here are some useful methods that are available in the list class. Add to add an object to the list. Add range to add a list of objects. That can be another list or an array. Remove to remove one object from the list. Remove at, which removes the object at the given index. Index of, which returns the index of the given object. Contains, which tells us if the list contains the given object or not. And count, which returns the number of objects in the list. Let's flip over to Visual Studio and see all these methods in action. Alright, in this video I'm going to show you how to work with lists, or more accurately, generic lists in C#. So let's create a list. We use the new operator to initialize an instance of the list class. Note the angle brackets here in the IntelliSense. That indicates that list is a generic type. And also note that it's defined in system.collections.generic. If you don't have ReSharper, the IntelliSense you see is going to be different. I don't think you're going to see the namespace, which means you have to go on the top of the file and type using system.collections.generic. Once you import the namespace, then you can come here and create a list. You specify a type here. So let's say we would like to create a list of integers. That's it. We can initialize this list ahead of time using the object initialization syntax. So I'm going to supply 1, 2, 3, 4 here. Now we can add something to this list. So numbers.add. I would add another one here. So this is the difference between a list and an array. In an array, we don't have an add method. And once we create the array, the size of the array cannot be changed. But in a list, you can add as many objects as you would like. We can also use the add range method to add more than one object to the list. So numbers.addRange. And note that in the IntelliSense here we see I enumerable of int. What is the I enumerable? Well, first of all, whenever you see a type that is prefixed with I, that is an interface. I have covered interfaces in detail in the second part of this course. So for now, we want to keep things simple. I want to give you a quick tip here. Whenever you see I enumerable in the IntelliSense in C#, you can use an array or a list there. Once you understand interfaces in the second part of this course, then you will realize that that interface is implemented by different classes like the array or the list, which means whenever you see I enumerable, you can supply an instance of a class that implements IEnumerable. Now, if all that sounds too complex, don't worry about it. Again, remember my tip, whenever you see IEnumerable, you can use an array or a list. So let me create an array here, new, int array. I'm going to specify the size of 3. And I can use the object initialization syntax to immediately initialize this array. 5, 6, 7. Now, it's very unlikely that you're going to write code like this in a real-world application. So don't be intimidated by this weird way of initializing a list. All I want to show you here is the number of possibilities when working with lists. You don't have to memorize anything. All I want you to take away here is an idea of what you can do with a list. So you can create a list like here. You can initialize it ahead of time. If you know the objects you want to store there, you can call the add method to add one object to a list, or you can call add range to add another list or an array to the list. Now, once we have a list, we can iterate it using a for each loop. So for each var number in numbers, console.writeLine number. Let's run the application. So we got 1, 2, 3, 4, 1, 5, 6, 7. Now let's take a look at the index of method. So numbers.indexOf. This method has a few different overloads. The simplest one, which is the one that is currently highlighted, means you can pass an item of type integer here, and this method returns the index of that object in the list, if it exists. Otherwise, it returns -1. The second overload of this method takes another parameter called index, and that's the starting point. So you can say start your search from index 3. And the third overload of this method specifies the number of objects to include in the search. The first overload is what you would be using most of the time. So let's see what's the index of 1. I'm going to display it on the console. Let me add a label here. So index of 1. And I would like to have a console.writeLine here to separate it from our for each loop. So index of 1 is 0. But interestingly, we have two ones here. Here's the first one, and here's the second one. We have another method called lastIndexOf. Let's take a look at that one. So I'm going to duplicate this line and instead use lastIndexOf1. Let's run the application. So lastIndexOf1 is 4. So sometimes you may want to start your search from the beginning of the list. In that case, you use indexOf method. Sometimes you want to start your search from the end of the list. When in the real world does that happen? I can't really tell you now because it really depends on the algorithm you're designing. Now, let's take a look at another useful member of the list class, count. So, count numbers.count. So this is a property that returns the number of objects in the list. Let's run the application. So currently we have 8 objects in the list. Now let's take a look at the remove method. So numbers.remove. I'm going to remove 1 from the list. Now let's iterate the list again and look at the result after removing 1. So I'm going to copy this for each block and put that here. Now let's run the application. So note that the first one is gone, but we still have another one. What if you wanted to remove all the ones in this list? So one way to do that is to use the for each loop. So let's change this example to something like this. We iterate the list one object at a time. We check if number is 1. Then we remove number. Once we do that, let's copy this for each loop again and put that here. Let's run the application. The application crashed. Why? We got an unhandled exception. Let me cancel here. This is an exception or an error that you may see from time to time when you are removing an object from a list inside a for each block. So look at the exception detail here. It's of type system.invalidoperation_exception. And the message says collection was modified. Enumeration operation may not execute. So what this means is in C# we are not allowed to modify our collection inside a for each loop. So inside this for each block we have this numbers.remove, which is modifying the collection. So how can we change this program to get the desired result without that exception? We need to use a normal for loop. So something like for var I is 0. Run this as long as I is less than numbers.count, then plus plus, and we move this code here. Now here we need to change that to numbers of I, because we don't have a local variable like the for each called number, right? So we need to access the current element in the list using an index, numbers of I. Okay, let's run the application. There you go. So we removed both ones from the list. And one last method before we finish this lecture. So let's take a look at the clear method, numbers.clear. So this method removes all elements from the list. Now if we display count on the console, we're going to get 0. So I'm going to grab this line here and paste that here. So look, the last count is 0. So this was an introduction to the kind of things you can do with a list. I hope you enjoyed this lecture and thank you for watching.
Okay, in this section, you learn more about C# arrays. You learn that in C# arrays have fixed size, which means once you allocate them, you cannot change their size. So if you want to work with a dynamic array, you need to use a list. Now these days, 99.9% of the time, we use lists, not arrays. But you might be working with a third-party library or a legacy codebase, and you may still have to use arrays. So remember the syntax, but prefer to use lists. I hope you enjoyed this section, and thank you for watching. In this section, I'm going to teach you how to work with dates and times in C#. And as part of this, I'm going to introduce you to two new types in .NET, datetime and timespan. So let's get started.
Okay, in this video, we're going to take a look at how to work with dates and times in C#. We have a type called datetime, which is a structure that is defined in system namespace. So type datetime, and you see the structure icon here, and that is defined in the system namespace. So there are a number of ways to create a datetime object. One way is to use the new operator. So datetime equals new datetime. And the constructor of this structure has multiple overloads. So look at the first one here. You can specify year, month, and day. Or if you want to be more specific, you can go up to hour, minute, and second. It has a bunch of different constructors. So we're going to keep it simple. 2015, January 1st. If you want to get the current datetime, you access datetime.now. So now is a static property of datetime structure. So I'm going to store it in a variable called now. Or if you just want today's date, irrespective of the time, you can use datetime.today. Now that we have a datetime object, we can access its components like year, month, day, minute, hour very easily. So here's an example. Now.hour or now.minute. So let's put a label next to it. And run the application. So currently it's 12:40 p.m. So there are a bunch of properties that you can access. I'm not going to go through each of them because I don't want to waste your time, but you got the point. One thing you need to know about datetime objects in C# is that they're immutable, which means once you create them, you cannot change them. So how do you modify them? There are a bunch of methods and they all start with add. So now.add. So you can add days, hours, milliseconds, minutes, and so on to an existing datetime object. So let me show you add days. 1. So this returns tomorrow current time. What if you want to go back in the past? You use a negative number. So yesterday equals now.add days -1. Very simple. And one last thing you need to know about datetime objects in C# is formatting them to a string. So a datetime object has a bunch of methods for converting it to a date or time string. So here are a few examples. Now.to long date string. I'm going to duplicate this line a few times. There's another one, to short date string, to long time string, and to short time string. Let's see the difference. I'm going to comment out these two lines so we can focus. Let's run the application. So note that with the first two, you only have a date component and not a time, whereas with the last two, there is just a time component. And obviously, this is the long date and here's the short date. Now, what if you want to display both date and time? You use toString method. So, toString. Let's take a look. So here is the current date time. We also have this concept of format specifiers. So toString method optionally takes an argument, and here's where we provide a format specifier. So take a look at the IntelliSense here. What you see on the left side is a format specifier, and on the right side you see an example of that. So let's take a look at this one where you display a date with the hash notation. This is very common in passing in XML or JSON. So take a look at this one. So if I want to output my date time to something like that, we can use this string as the format specifier. So I can use YY for a 2-digit year or 4Ys for a 4-digit year. I can use M and D. Let's run the application. So here's the result. We can also add time to it. So let's take a look. H:\M. So currently it's 12:46 p.m. There are a bunch of format specifiers and you don't need to memorize them. If you want to look at the full list of them, simply go to Google and search for C# datetime format specifier. On the first link, custom date and time format strings. So here you can see various examples of these format specifiers, their full list, and examples for each of them. In the last lecture, you learned about datetime, which represents an exact date and time value. We also have a type called timespan, which represents a length of time. There are a few different ways to create a timespan. The simplest one is to use the new operator. So, timespan equals new timespan. And note that the constructor has multiple overloads. In this case, I'm going to use the third one, which takes hours, minutes, and seconds. So let's say 1 hour, 2 minutes, and 3 seconds. What if we didn't have a value for minutes and seconds? We could just pass 0. So here is an example. 1 hour, 0 minutes, 0 seconds. The only issue here is when you look at this timespan object, sometimes it's not quite clear what do these zeros represent. Is it the hours, minutes? It's not quite clear. So a more readable way to create the same timespan object is use two static methods on the timespan structure. So timespan has a bunch of static methods, and they all start with from days, from hours, milliseconds, minutes, seconds, and ticks. So I can just use from hours and pass 1 here. And note that between these two lines, the second one is more readable. There is also a third way to create a timespan. If you have two datetime objects and you subtract them, the result is a timespan. So something like this. So end minus start returns a timespan. In this case, that timespan represents 2 minutes. Let's display it on the console. So here is the result. 2 minutes, and it has a slight millisecond value. I think it's because of the datetime.now. So at the time that we read this value, there was a tiny millisecond component in the current datetime. Okay, so this is all about creating timespan objects. Now, once we have a timespan object, we can read its properties very easily. So, each timespan has a number of properties that come in pairs. What do I mean by that? Look at this timespan. It has properties like days, hours, milliseconds, minutes, seconds, and so on. But it also has pair properties that start with total. So, total days, total hours, milliseconds, and so on. What is the difference? Let me show you with an example. So, I'm going to duplicate this line. And this time, I'm going to display total minutes. So, the minutes property returns the minutes component of your timespan object. So in this case, our timespan is here. The minutes component is 2. So that's what's returned from minutes. Total minutes converts that timespan object to minutes. So in this case, it's going to return 1 hour, which is 60 minutes, plus 2 minutes, plus 3 seconds, which is a fraction of a minute. So let's take a look at the result. So as you see, minutes is 2, whereas total minutes is 62.05. Next, similar to the datetime object, a timespan is immutable, which means once you create it, you cannot change it. But it provides a couple of methods to modify its value: add and subtract. Both these methods return a new timespan. So let's take a look at a couple of examples. So what I'm going to do is, this time I call the add method. Note that this method takes a parameter of type timespan. So here I can create another timespan. I can either use the new operator, or I can use one of the static methods. So let's say timespan from minutes. So I add 8 minutes to our original time span. So it was 1 hour, 2 minutes and 3 seconds. So now it's going to be 1 hour, 10 minutes and 3 seconds. There you go. Subtract is very similar. So I duplicate this line. Subtract. Again, this method takes a time span object. So let's subtract 2 minutes from our original time span. And the result should be 1 hour and 3 seconds. There you go. 1 hour and 3 seconds. Now, one last thing you need to know about time span is conversion to and from strings. So let's scroll down. If you want to convert a time span to a string, you simply call the toString method. But note that in this case, toString is grayed out. What does it mean? That means console.writeLine by default calls this method on any object you pass to it. So you don't have to explicitly call it. But if you're not using console.writeLine and you need to convert a time span to a string value, simply call toString. How about conversion from a string? We use the parse method. So time span dot parse, that takes a string. So let's say 1 hour, 2 minutes and 3 seconds, and that returns a time span object. In this case, we pass this time span object to console.writeLine, and this method automatically applies toString on our time span object. Let's take a look at the result. There you go. So parse 1 hour, 2 minutes and 3 seconds. That's pretty much all you need to know about time span. I hope you enjoyed this lecture and thank you for watching.
So, in this section you learned about two new types in .NET. Datetime, which represents a point in time, and timespan, which represents a duration. Remember, both these types are structures and are immutable, which means once you set them, you cannot change them. So let's say if you create an instance of datetime and call one of its methods like addMonth or addHour. In all cases, these methods return a new instance. I hope you enjoyed this section and thank you for watching. In this section, we're going to take a closer look at C# strings. So I'm going to introduce you to a few new methods in the string class and a new class called String Builder. So let's get started.
Earlier in the course, you learned that in C#, the string keyword maps to the string class in the .NET framework. So a string is a class. And you also learned that strings are immutable, which means once you create them, you cannot change them. In this lecture, I'm going to cover a bit more details about strings. I'm going to introduce you to some useful methods to work with strings, and then I'm going to show you how to convert a string to a number and vice versa. So I've categorized these methods into different groups. In terms of formatting your string, you can use toLower to convert all characters to lowercase, or you can use toUpper for converting that to uppercase. Trim is a useful method which gets rid of the white spaces around a string. And this is important when you capture user inputs in web forms or Windows forms. If you want to search for a character or a string inside a given string, you can use the indexOf or lastIndexOf method. Both these methods have overload and they accept either a character or a string. And they return an index of the first or the last occurrence of the given character or string in your string. If you want to create a substring from a given string, you use the substring method. This method has a couple of overloads. One that takes a start index and then retrieves all the characters from that point onwards to the end of the string. The other overload takes a length argument to limit the number of characters to retrieve. If you want to replace a given character or a given substring in your string, you use the replace method. We have a couple of methods here, is null or empty and is null or whitespace. And that's a common way to compare a string against null or empty string or whitespace. If you want to split a string, you can use the split method. In this example, I'm splitting a string by an empty character, which means if we have a sentence with multiple words, since there's an empty character between each of these words, they will all be split, and what will be returned from this method is an array of strings, each element containing a word. It's a very common technique to summarize a long string into a smaller one. I will show you that in the coding demo. There are times that you get a string representation of a number and you need to convert it to a numeric value. For example, in most applications, when the user types in a number into a text box, we always get a string, even if that string is a number. So we need to manually convert that to a number. There are a couple of different ways to achieve this. We can use integer.parse, or we can use convert.toInt32. I personally prefer convert_to_int32 because if the string is null or empty, this method returns the default value for the integer, which is 0, whereas int.parse throws an exception. So it's easier and safer to work with convert_to_int32. And finally, if we have a number and we would like to convert it to a string, we can use the toString method on that number. We can call this method without any arguments, which means you can get a string representation of that number. Or you can format that number using a format string. So in the third line here, C is a format string, and that's short for currency. So as you see in the example, when you format a number to currency, you get the $sign, and every 3 digit is separated by a comma. And by default, when you format a number as currency, it's going to have 2 decimal point numbers. If you don't want decimal point, you can use C0. Or if you want 1 decimal point, you can use C1. Here is a list of common format specifiers in C#. So C for currency, D for decimal, E for exponential, F for fixed point, and X for hexadecimal. Alright, now let's flip over to Visual Studio and let's see all these concepts in action. Alright, let's take a look at some of these useful string methods. So here I've got a variable, full name, with my name. And note that there is a whitespace character at the end of this string. So first, let's take a look at the trim method. Trim gets rid of the whitespace at the beginning or at the end of a string. So, console the right line. I'm going to use a format string here. So, 2 single quotes, and I'm going to put a placeholder here. The reason for that is because I want to enclose my string with single quotes so you can see the effect of trim method. Now let's apply some value here. So full name dot trim. Okay, let's run the application. Note that the whitespace at the end of my name is gone. So this is very important when you receive input from the user. Sometimes you need to trim a string before doing processing on that. Otherwise, if you're going to compare that string with another string, comparison is not going to work. All right, let's take a look at the toUpper method. So I'm going to duplicate this line and change the label to upper. Note that here we can chain these methods because each of these methods on the string class return a new string. They do not modify the original string. And that's what I meant by strings being immutable. So dot toUpper. Let's run the application. There you go. Now let's say we want to break this string into first name and last name. How do we do that? There are a couple of different ways. One way is to look for the index of the space, and based on that, split that string into 2 parts. So let's try that first. So full name dot index of. You can supply a character or a string here. So I'm going to use a white space character. Now, based on this index, we want to split the string. So we can declare first name as full name dot substring. Now, this method has two overloads. Look, the first one takes only an index, which is the starting index. So it starts from that index and goes to the end of the string. The second overload here takes a start index and a length, that is the number of characters to include. So I'm going to use this overload to take the first name. What is my starting index? That's 0, the beginning of the string. How many characters do we want? Up to the index of space. So that's going to be index. And last name. Now this time I'm going to use the first overload. So I'm going to start from index plus 1 all the way to the end of the string. Let's put these on the console. Okay. There you go. So first name Mosh and last name Hamedani. Now there is an easier way to achieve the same thing, and that's using the split method. So if we call split, we can supply a character or a string here. So if I supply the white space character here, look what we get in the result. The return type of this method is a string array. So I store the result in a variable called names. So if I hover my mouse over var, look, it's a string array. Now I can easily get the first name as names of 0 and last name is going to be names of 1. Let's run the application. There you go. We got the exact same result. So if you're working in scenarios where you want to split strings, the split method is easier to work with. Otherwise, if you have some more complex processing, you can use the index of and substring methods. Now let's take a look at the replace method. Let's say we want to replace my name here, Mosh, with my actual first name, which is Moshfak. So full name dot replace Mosh with Moshfak. Again, here you can supply a character or a string. For example, you can say, let me show you another example. You can say replace lowercase o with uppercase O. Or you can say replace white space with nothing, with an empty character. And this is exactly the effect of applying the trim method. Okay? Now, the important thing to remember is, as I told you before, all these method calls return new strings. So the original string is not affected. So let me get rid of these two lines here and display this on the console. Run the application. Look, Moshfak Hamedani. Now let's take a look at a couple of useful methods to work with empty strings or nulls. So in real-world applications, sometimes when you get input from the user, you want to see if the user actually put a value there or not. For example, imagine you're building a form and the user is supposed to supply a credit card number. You want to make sure that the user did enter a credit card number. So how do we validate that? Let me show you. So look, if string is null or empty, so this is a static method on the string class, and it takes a parameter. I can supply null here, and here we display an invalid message. So what do you think is the output of this program? We should get the invalid message because here I have passed null as an argument. So let's just verify that before we go to the next step. Okay, we got the invalid message here. Now, what if I put an empty string? We should still get the invalid message. Look, it's here. So far, so good. But what if the user just enters a space like this? Technically, this is invalid. This is not a valid credit card number. So this is equivalent to user not providing any numbers at all. Let's run the application. Look, we no longer see the invalid message here. So this method was one of the first methods that Microsoft put in .NET Framework. So to work around this problem, what we had to do was trim the string first and then pass it to isNull or empty method. Let's run the application. Okay, we see the invalid message now. But this is a little bit tedious and ugly. That's why in later versions, Microsoft introduced a new method. isNull or whitespace. Now we no longer have to trim. So if the string is empty or whitespace or null, we're going to get the invalid message. There you go. And before we finish this lecture, let me show you how to convert numbers to strings and vice versa. So let's say we receive a number from the user. And if you're building web or desktop or mobile applications, always these inputs come as a string. So you need to convert that to a number. Let's say we get an input, which is the user's age. Let's say 25. So we need to convert this string representation of number 25 into an actual number. There are two ways to do this. One way is to use the convert class. This class has a number of methods and they all start with 2. Like 2 in 32, 2 in 64, to double, to decimal, to date time, to char, to byte, to boolean, and so on. So in this case, if I want to convert this str to, let's say, an integer, I would use convert to int 32. Now, integer is 4 bytes, and we only need 1 byte to store someone's age, because no one can be older than 250 years old. So then we can change this to 2 byte. And now we can store the result here and display it on the console. Now let's take a look at the other situation. We have a number, we want to convert it to a string. So let's say we've got a price here, and that is $29.95. We want to convert this to a string. We can use price dot toString. So every object in .NET has a toString method. The reason for that is beyond the scope of this course, and that's something that I have covered in my C# intermediate course. For now, just remember this toString method is available everywhere. Now, you can call this method without any argument, which simply returns a string representation of this number. But I want to format this as currency. So I supply a format string. So here in the IntelliSense, look, capital C is currency. And by default, it has 2 digits after decimal point. If you don't want decimal point, you can use C0. Or if you want one number after decimal point, you can use C1. So let's just convert this to currency and display the result on the console. Okay, so there you go. $29.95, and we get the dollar sign. Now let's get rid of the decimal points. So I put 0. So it rounded that to $30. Okay, that brings us to the end of this lecture. I hope you enjoyed and thank you for watching. Okay, in this lecture, we're going to work on an interesting problem. Summarizing text. You have seen on a lot of blogs, on the homepage, there is a list of blog posts. And below each post, there is a summary. And at the end of the summary, you see ... How do we do that? So let's start by declaring a variable. This is going to be a really long text. And we want to summarize it. The first thing we want to do here is to check if the length of this sentence is below a given threshold. If that's the case, we simply display it. Otherwise, we need to summarize it. So, if sentence.length is less than 20, just an arbitrary number, we simply display it. Otherwise, we need to summarize the text. Now, the first thing I want to improve in this code is to get rid of this 20 as a magic number. I would like to express it using a constant. So constant integer maximum length. This way we don't have to spread that 20 all over the code as a magic number. And the code is more expressive now. Alright, now how do we summarize this? The poor way of doing that is to use the substring method like this. So starting from index 0 and taking maximum length. What is the problem with this? The problem is you may cut off a word as a result of that kind of substringing. And that's not a good thing. We want the summary to look clean. So we want to take into account the word boundaries. So the algorithm we're going to work on here is to count a number of words that roughly fits around 20 characters. How do we do that? The first thing we want to do is to break this sentence into words. So we use the split method and we use the white space as a separator. Now we are going to have a string array of words. Note that words is a string array. Now we can iterate over this array. For each word, we count the length of that word, add them all together. If we roughly get around 20 or exceed 20, that's a boundary where we need to cut off. So I'm going to declare a variable here called total characters, set it to 0. Now we're going to loop over the words. So a simple for each block. For each word, we need to get its length and we need to add it to total characters. So total characters plus equals word.length. And we also need to add 1 because of the space after that word. Now, if total characters exceeds 20, that's the time to get out of the loop. So immediately break. Now, one more thing we need here is a list to dynamically store all these words that are going to be part of the summary. So summary words is going to be a list of string. You learn about lists in the section about arrays and lists. So a list is a data structure similar to array where we can store a number of objects of similar type, but the size is dynamic. So now in the loop, we need to add the current word to our list. Then we do our checking to see if the total number of characters exceeds max length, then we break. So once we get out of this for each loop, our summary words list has all the words that need to go in the summary. What we need to do is to create a string and join all these words using a white space. How do we do that? The string class has a method called join. The first argument is a separator, so we use a white space. And we can pass our summary words list here Now this join method returns our summary string. All we need to do is to append ... at the end, and that's going to be summary. Let's display it on the console and run the application. Note that we didn't cut off a word. Now in a real world application, it would be nice to extract all this logic here into a separate method or a separate function, so we can reuse in different places. So what I'm going to do now is create a new method here. So this is the end of our main method. We can create another method here, and that method has to be static because our main method is static. So in order for us to call that method from the main method, we need to declare it as static. So static, the return type of that method should be a string. Let's call it summarize text. That takes a parameter of type string. Call it text, like that. And I'm going to move all this logic here. The only problem is we used the word sentence before, now we use text. So we can replace text. So we need to replace it. With ReSharper, it's pretty easy. Alt and Enter, change all sentence to text. If you don't have ReSharper, you need to manually go through each of these and modify them. Now at the end, instead of displaying it on the console, we need to return it. So return summary. And also we need to modify this one here. So if the text is short enough, we don't need to summarize it. We just return it. Now ReSharper is telling me that we don't need this else block here, the else keyword, because it's grayed out. Because if the text is more than max length, obviously the rest of this method is going to execute. So we don't need to explicitly use else here. So we can clean up the code like that. I select all of that, Shift and Tab to format it. We can make this code even cleaner because it's obvious that this method is returning a summary text, so we don't need to store this result in a variable and return it. We can simply put this expression here. Another thing we can do here is to have a second parameter here that specifies max length. So instead of hard coding the number 20, we give this option to the caller of this method to specify the max length. This way we increase reusability. So int max length, and we can give it a default value of 20 in case the caller of this method does not want to set the max length. And we get rid of this constant integer. And finally, back to our main method, we can create another variable called summary, call our summarize text method, and pass that long sentence here, then display it on the console. Let's run the application. We got the same result. Now, we can go and change the max length here. So let's say max length is going to be 25. Let's see what happens. So we got one more word in the summary. Again, we are not cutting off text in the middle of a word. Now we have a clean, reusable method that we can use in different places. And one last thing I would like to do here to improve the reusability of this method is, instead of declaring that inside this program, I want to put it in a class that I can use in different programs. Because in the real world applications, we're not going to write all of our code inside the program class. We're going to have different classes for different reasons. So let's add a new class to this project. Add class. Let's call it string utility. And now we go back to program here. We select this method. If you're using ReSharper, you use Control W to quickly select a block of text like this. It's much faster than holding down the Shift and using the down arrow like that. So Control W, and you can extend your selection like that. Or Control Shift W, you can reduce the selection. Cut. Now with Control and Tab, we switch window. And here, drop it. And finally, we need to make this class public. As I explained in the beginning of this course, we're going to just work with public classes and public methods in this course. Public is an access modifier, and I'm going to explain access modifiers in more detail in the second part of this course called C# Intermediate. And of course, we need to make this method public as well, otherwise it's not going to be accessible. Let me show you. So if you go back to program, and now we need to change the summarized text to string utility dot. See, there is nothing there because we didn't declare the method as public. So Control Tab, back here, add the public here, back to the program. Now if we put dot here, we see that utility method. All right, that brings us to the end of this lecture. I hope you enjoyed it, and thank you for watching. So earlier in the course, you learned that the string class is immutable, which means once you create a string object, you cannot change its content. If you're dealing with situations where you have a lot of string manipulation operations, you can use a string builder. String builder is a class that is defined in the system.text namespace and represents a mutable string. It makes it really easy and fast to create a string and modify it on the fly. But unlike the string class, it's not optimized for searching. So it doesn't give you methods like index of, last index of, contains, starts with, all these string searching operations. Instead, it provides a number of useful methods for manipulating strings, like append to add something to the end of a string, insert to add something at the given index, remove to remove something from the string, replace to replace a character or a string, and clear. Let's flip over to Visual Studio and see String Builder in action. Alright, in this video we're going to have some fun with the String Builder. So let's create an object of type String Builder. Let's call it Builder, String Builder. Note that as I typed new String Builder, ReSharper automatically added using system.text on the top. If you don't have ReSharper, obviously you have to add that namespace yourself. Now let's explore some of the methods of String Builder. So, Builder, we have three append methods. Append, append format, and append line. We're going to go through each of them. Let's take a look at the append method. This method has a few different overloads. One that takes bool, another one takes byte, one takes character and repeats that, and one that takes a character array. Let's use the one that is currently highlighted here. So I would like to have this dash character repeated 10 times. Now let's display it on the console. So that's what we got. Now, let's add a new line here so we can use append line. And after that, we can use append again and display some header. Let's call it header. We can have another new line. And finally, we can have those dashes again. Let's run the application. So, see, we easily created something like that. Now, it's not always about creating something that looks good. It's about manipulation of strings. Like earlier in the course, we had a lecture on the random class. And there I showed you how you can create a random string, like a random password. In that lecture, I showed you how to use a character array to store your random characters. Now that you learn about String Builder, you can use a string builder to generate a random sequence of characters. Let's look at other methods. So we can say replace all these dashes with the plus sign. Let's look at the result. There you go. Very easy. Or we can call remove and say start from index 0 and remove 10 characters. Let's see what happens. So the line on the top is gone. Or we can use the insert method. With the insert, we need to specify an index. So we can pass 0 here to put something at the beginning of the string. And as the second argument, we can pass anything. We can create a new string here and use this overload here, specify a character and a count. So dash and 10. So we're going to repeat that 10 times. So basically with that, we're going to add a line of those dashes at the beginning of our string builder. Let's look at the result. There you go. So you see, string builder makes it really easy to modify strings. And also it's faster than using a string and using its manipulation operations, because those string manipulation operations like replace, insert, remove, all these methods create a new string object in the memory and return that. And if you have a large number of string manipulation operations, that extra creation of strings can be a little bit costly. So you can use a string builder, and this way your program is going to be even more efficient. Also note that when you create a string builder, you can also specify a starting string. So let's set it to hello world, and then we can do all these other manipulations after. Let's look at the result. Now, interestingly, after all these manipulations, the first part, hello world, is removed and only D is left, and the rest is replaced by some dashes. So string builder is really easy for manipulating strings. But what you need to remember here is that with string builder, you're not going to get string searching methods. So builder dot, see, these are all about manipulation. We don't have any methods to search for the index of a character or a string inside that string builder. And one last thing is, you can use an indexer to access individual characters in the string builder, just like how you do with a string. So if I want to display the first character, I just use index 0. And let me add a label here. And run the application. There you go. First character. And one last thing I want to show you here is actually very interesting. Look at the signature of the append method. That returns a string builder. It's not a void method. It returns a string builder, which means we can chain these append methods all together and make our code cleaner. So this append method returns our builder with the updated string, and then right after that, we can call this second append method. And again, this append line returns the updated string with a new line. Now we can append the rest to it. We need to get rid of semicolon here. Same here, and chain them together. This makes the code less noisy and more readable. And the same is true for other methods here, like replace, remove, insert. All these return a string builder. So again, I can go here and chain all these methods. Just like that. So the code is much nicer, much cleaner. So that's pretty much all about Stream Builder. I hope you enjoyed this lecture and thank you for watching. Okay, in this lecture, I'm going to introduce you to a very important topic, procedural programming. So what is this all about? Well, procedural programming is a programming paradigm based on procedure calls. So by procedure, I mean function, method, routine, subroutine. These are all the same thing. So far, all the code you have written in your exercises was in the main method, but that's not how we build real-world applications. Because a real-world application includes quite a number of functionalities, and writing all that code inside the main method is going to be a disaster. So we need to break down our code into a number of methods or functions, each responsible for one thing. And this is what we call procedural programming. We also have object-oriented programming, which is another programming paradigm which is based on objects. So instead of thinking in methods and functions, we think in objects. And that's the topic of the second part of this course. But for now, because we want to take things on a step-by-step fashion, I want to make sure that you really understand procedural programming. And the best way to understand that is by doing it. So, in this lecture, I'm going to show you how I would go about extracting some logic from the main method into a separate method. I'm going to do a couple of examples, so I want you to pay full attention. And once you see how I do it, then I want you to go over the code you have written in this section for the exercises and apply this technique. If you couldn't solve all the exercises, that's okay, don't worry. You can look at my solutions and extract methods from the code I have written. So let's flip over to Visual Studio and see procedural programming in practice. Okay, this is the solution to one of the exercises we had earlier in this course. We asked the user to type their name, and then we reverse the name using an array. So currently everything is written in the main method. How can we extract a method or a function from this logic? The first rule of thumb: you should always separate the code that works with the console from the code that implements some logic. So in this example, over the first two lines, we get the user's name. Then here we have some business logic, which is where we use an array to reverse the name. And here is where we return the reverse name as a string. And finally, we display the result on the console. So let me put a line break here. So this last line and the first two lines is all about working with console. We want to make sure that we separate this logic from the logic that is responsible for calculating the reverse of a name. Why? Because in the real world, we have different presentation technologies. We have desktop applications, web applications, mobile apps, and there we don't have console. So by extracting this logic here that is highlighted into a separate method, we can reuse that method in any application. Console is only relevant in console applications. So let's extract this logic into a separate method. First, we start with the access modifier, public. Then we need to use the static keyword. And the reason for that is because we are in the main method and main is a static. In order for us to call this method from the main method, this method should be static as well. Now we need the return type. What do you think is the best return type for this method? Should it return an array or a string? Well, what do we expect here? We need a string to display on the console. So, return type is going to be a string. Now, give it a name. Reverse name. Make sure your method names are meaningful. I should be able to look at your method name and know exactly what this method is doing without looking at its code. Now, parameters. Do we need any parameters? If yes, how many? Of what type? Well, all this method needs is that initial name, this variable here. So all the processing is done on the name variable, which is a string. So this method should take a string parameter called name and return another string, which is the reversed version of that name. Now, I simply cut and paste this code here. In the last line, we need to return reversed variable. Okay? And now we can change our main method such that we call our new method reverse name and pass this name here and display the result. So look, the code is more maintainable now. Instead of everything being in the main method, we have two methods, each responsible for one thing. The main method is purely responsible for getting the input from the user and displaying it. And the reverse name method is purely responsible for reversing the name. Now, one more improvement we can do here is this variable here, reversed. I see that as a bit of noise because the name of this method, reverse name, is telling me that what is coming out of this method is the reverse name. So we don't need to store it in a separate variable. We can simply get rid of it and return the result straight away. And this way, the method is shorter and easier to understand. Let's take a look at another example. Okay, here's the solution to another exercise in this course. So we ask the user to continuously enter a number or type quit to exit. Then from that list of numbers, we find the unique numbers and finally display them here. So what part of this code can we extract into a separate method? Again, remember my rule of thumb. You need to separate what is about working with console from what is about the logic of your application. So in this case, this is the core logic. Getting the list of unique numbers from a list. So I'm going to extract this into a separate method. Public, static. What should be the return type of this method? It should return a list of integers. Now we give it a name, get unique numbers. Now what should be the parameter? List of integer. Let's call it numbers. And now we can cut and paste this here. So finally, we return this Unix variable here, which is a list of integers. And in the main method, we can assign this variable to a call to get unique numbers of numbers. That's one way. Another way is, because this is kind of a noise, we can simply call this method inside the for each block. Okay, so now we have a reusable method that we can use anywhere, anytime, where we have a list of numbers and we want to get the list of unique numbers in that list. Now it's your turn. I want you to go over the exercises in the string section, the ones you did just before this lecture, and extract methods or functions or procedures from your code. If you get stuck, you can always look at my solutions.
So, in this section, you learned more about C# strings. You learned that strings are immutable, which means once you set them, you cannot change them. So if you're working on a problem that involves a lot of string manipulation, it's better to use the string builder class. This class is optimized for string manipulation and does not provide methods for searching in strings. In the next section, we'll take a look at working with files and directories in C#. I hope you enjoyed this section and thank you for watching. In this section, I'm going to teach you how to work with files and directories in C#. And as part of this, I'm going to introduce you to a few useful classes in .NET. File, file info, directory, directory info, and path. So let's get started.
Okay, in this section I'm going to talk about how to work with files and directories in C#. In .NET, we have a namespace called system.io, and that's where all these classes to work with files and directories are located. There are many classes in this namespace, and it's really impossible for me to go through all of them. First of all, it's going to take a lot of time, and honestly, I don't have the knowledge of every single one of them. In fact, I don't think there is anyone on this planet who knows every single class in .NET Framework. So you will discover classes based on your needs. But in this lecture, I'm going to introduce you to a few very common classes that you might find useful in your programs. These classes include file and file info, directory and directory info, and path. Let's see the difference between them. So file and file info classes both provide methods for creating, copying, deleting, moving, and opening files. They have very similar interfaces. The only difference is file info provides instance methods, whereas file provides static methods. So why do we need different classes for static or instance methods? The difference is if you're going to have a small number of operations, let's say get attributes about a file, it's more convenient to access the static methods of the file class. But the problem with these static methods is every time you call these static methods, some security checking is done by the operating system to make sure that the current user has access to the file. So if you're going to have a large number of operations, this is going to affect the performance of your application. So in that case, it's more efficient to create a file info class and access all its instance methods. This way, security checking is done only once during creation of a file info object. So here is a list of methods that are pretty useful to know about these classes. Again, this is not a complete list by any means. My intention is to just give you an idea of what you can do with these classes. So create method is of course used to create a file. We also have copy, delete, exists to check if a file exists. Get attributes, which returns the attributes of the given file. Or move to move a file around. Or read all text, which reads all the text in a file. Directory and directory info are very similar to file and file info. So directory class provides static methods, whereas directory info provides instance methods. And you use either of these classes to work with directories. Here are some useful methods. Create directory, delete, exists, get current directory, which returns where the application is currently sitting. Get files, which returns the files in a directory. And in that method, you can provide filters. For example, you can say, give me all files or files with a JPG extension. We also have move and get logical drives, which returns the logical drives of your hard disk, like C drive, D drive, and so on. We also have the path class, which provides methods to work with a string that contains a file or directory path information. And here are some useful methods of the path class. Get directory name, get file name, get extension, which is very useful. Let's say you have a path and you want to get only the extension of that path. So you don't want to process a string yourself, you just want to get the extension. So you simply call path.getExtension and provide your string there. We also have get temp path, which returns the path of the current user's temporary folder. In the next few lectures, you're going to see demos of these classes in action. Okay, in this video, I'm going to show you how to work with file and file info classes. These classes are very similar, and they both provide methods to work with files. The only difference is file provides static methods, whereas file info provides instance methods. So let's take a look at file. Look, here are the static methods of the file class. You can copy a file, create a file, decrypt an encrypted file, delete it, encrypt it, check if it exists, and see there are lots of methods here. It's really impossible for me to go through all of these methods. I'm just going to show you a few of them in this lecture, so you will have an idea of how to use them. Then you can go and use the other methods depending on your needs. So let's take a look at copy. This method takes two parameters. They both are string. The first one is the source file name. So let's say we would like to copy a file that is located in the C drive in the folder temp, and it's called myfile.jpg. And the second parameter is the destination file name. Read the tooltip. It says this cannot be a directory or an existing file. So let's say we would like to copy these to D drive in the same folder and call it myfile.jpg. This method has two overloads. The second overload takes a parameter of type boolean, which you can use to indicate that if the file exists there, you can overwrite it. Now, first thing I want to do here to clean up this code is get rid of all these double backslashes. So that's where we can use a verbatim string. We simply put an @ sign here and get rid of all these noisy backslashes. That's it. Let's take a look at the delete method. Again, this method takes a path. So what I'm going to do, I'm going to declare a variable here called path so we can reuse it in different methods. Just like that. We can check if a file exists on the disk. So if file that exists, this method again takes a path and returns a boolean. Then we can do something about it. And finally, if you want to read all the text in a file, we can use file.readAllText. This method returns a string. Or if you want to read a file as binary, we can call readAllBytes, which returns a byte array. So let's try this one. Again, this method takes a path and returns a string. So we call it content. Now let's take a look at the equivalent methods in the FileInfo class. So with the FileInfo, first we need to create an object. And of course, we need to specify a path here. And then if you want to copy this file, we can call copy_to method. And this method takes a parameter of type string called destination file name. Again, we can supply whatever here. And note that this method also has an overload, which takes a second parameter called bool overwrite, similar to the other method. I'm going to leave it for now. Or if you want to delete it, FileInfo.delete. Takes no parameters. To check if the file exists, FileInfo.exists, which in this case is not a method, it's a property. So if FileInfo.exists, then we can do something about it. And finally, note that FileInfo does not have a readAllText method. It's only available as a static method in the file class. With the FileInfo, you need to call openRead, which returns a file stream. File stream is a different way of reading a file, and personally I'm not a fan of that because it's just a little bit complex. Later in this section, I will show you a very simple way to read the file if you don't want to use file.readAllText. But the bottom line here is, note that both these classes are very similar in terms of usage. The only difference is file provides static methods, whereas FileInfo provides instance methods. So if you want to execute a small number of operations against a specific file, it's more convenient to use these static methods. So you don't have to create a new FileInfo object. But with these static methods, every time you call them, the operating system does some security checking. And that can affect the performance of your application if you have a large number of operations. In that case, it's more efficient to create a FileInfo object and call the instance methods on that object. That's it for this lecture. I hope you enjoyed it, and thank you for watching. Okay, in this video, I'm going to show you how to work with directory and directory info classes. Again, to keep this practical, I'm only going to demonstrate a few of common and useful methods in these classes. So you get an idea of how to use these classes. Then I will point you to the MSDN documentation so you can look at the other methods available in these classes in case you need to know about them. So similar to file and file info, directory and directory info provide static and instance methods. Let's take a look at directory. So directory dot create directory, and this method takes a path. So we can use a verbatim string here. Say C drive in temp folder 1. As easy as that. If you want to get the files in a given directory, you use directory.getFiles. This method has 3 overloads. The first one takes a path. The second one takes a path and a search pattern. So you can filter and say, give me all the files with the JPG extension. And the third overload of this method takes a parameter of type search option, which is an enumeration. So as an example, C drive, projects, C# fundamentals. Let's take a look at all files. So that's my search pattern. And now I'm going to use search option.all directories. So this method returns all files in the current directory and its subdirectories. Let me show you the return type of this method. So we remove the parentheses and open it again. Look at the return value. It's a string array. So we can use a for each loop to iterate over this array. So I can store the results in a variable called files. And then do a for each. And display the result on the console. Let's run the application. So you see it's returning all files in every directory and every subdirectory starting from C drive, projects, C# fundamentals. We can change the filter here to say show me only SLN, which is Visual Studio Solution files. Let's take a look. So you see I've got a small number of solutions here. Now let me show you another example. This time I'm going to call get directories. So it returns only the directories inside this path here. So projects, C# fundamentals. And specify search option.all directories. So we get all directories recursively. Now let's use a for each loop here. And display the result on the console. I'm going to comment out these few lines so we can see the difference. So note that now it's returning only the directories. If you want to see if a directory exists or not, you simply call directory.exists, and here you specify the path. So you see all these methods are pretty simple, and you don't need me to go through each of them and waste your time. You can learn about them yourself. The only thing I want to show you in this lecture is the difference between directory and directory info. So it's exactly like file and file info. So I'm going to show you one example. I create a new directory info, specify a path here, whatever. And now if I want to get all files or all directories inside this directory info object, simply directory info.get files or get directories. So this method is exactly like the other method. It takes a search pattern and an enumeration called search option. Now that's pretty much all I wanted to show you about directory and directory info. If you want to learn about individual methods in the file info, directory, and directory info classes, simply go to Google and search for, say, file info class C#. Then pretty much in all cases, the very first link on Google is the documentation for that class on the MSDN, Microsoft Developer Network. So let's go here. So here's the official documentation of file info class. You can scroll down and look at each of these properties and their description. Same for the methods, all here with their description. Let's take a look at one of them here. Let's say encrypt. Now we scroll down here and look, there's already an example for you here. So it's not rocket science. You can easily figure it out on your own. I hope you enjoyed this lecture and thank you for watching. In this video, we're going to take a look at the path class. This class provides a number of methods that makes it really easy to work with a string that represents a path and extract different parts of that path. So we don't have to do the string processing ourselves. So here's an example. Imagine we have a path like what you see here. If I want to extract only the extension here, SLN, the poor way of doing that is to use the string class and search for index of, say, dot, and that would return the dot index, right? And then I can say path.substring from that dot index, and that would return the extension. So we don't want to do this low-level string processing ourselves. And that's when we use the path class. So with the path, we can say get extension. Note that this is a static method. We can provide our path variable here and simply display the result on the console. Let me add a label before it. And run the application. Look, it returned .sln. Or we can use getFileName to only extract the file name in that path. So filename plus path dot get file name. It also has another method called get file name without extension. So this time get file name without extension. We change the label. And another useful method is get directory name. So I change the label here. Get directory name. Let's take a look at the result. So note that get file name only returned the file name with the extension. If we call get file name without extension, this is what we get. And if we call get directory name, it returns the directory in which that file is sitting. So this class makes it really easy to work with a string that represents a path. In case you need to use this class in your program, I encourage you to look at MSDN documentation to have an idea of all the methods that are available there so you don't have to reinvent the wheel. That's it for this lecture, and I will see you in the next lecture.
So in this section, you learned about different classes in .NET to work with files and directories. These classes come in pairs, like file and file info. File provides static methods, whereas file info provides instance methods. Which one do we use? Depends on the number of operations. If you have small number of operations, it's easier to use the file class because you don't have to create a new object. But remember, every time you access a file, there is some security checking done by the operating system. And if you have a large number of operations, it's going to be costly. So it's more efficient to use the file info class in those cases. And the same applies to directory and directory info. And remember, if you need to access individual parts of a path, like the extension, file name, directory name, it's easier to use the path class as opposed to string searching methods in the string class. I hope you enjoyed this section, and I will see you in the next section. In this section, I'm going to show you a few techniques to debug your applications. I'm going to show you how to use breakpoints, watches, call stack, locals, and autos windows. I'm also going to talk about some good programming practices such as defensive programming. So let's get started.
In this video, I'm going to teach you how to debug your applications. So I've written a small program that displays the smallest numbers in a list. So as you see on the first line, we define a list of integers with numbers from 1 to 6. Then we call this method getSmallest. We pass our numbers list here, and 3 here means return 3 smallest numbers in this list. And finally, we iterate over this smallest list and display them on the console. So before we get a closer look at the code, let's run the application and see what's wrong here. So with Control and F5, so instead of getting numbers 1, 2, 3, we're getting 6, 5, 4. So this is not the list of smallest numbers. Let's see what's happening here. So we have 2 methods, getSmallest and getSmallest. Let's expand this method. So in this method, first we define a list to hold the smallest numbers. Then as long as the number of elements or the number of objects in this list is less than the count that we pass to this method, we're going to run this logic. And here, we make a call to getSmallest method, passing the list, and we expect this method to return the minimum number in that list. Next, we add this minimum number to our ultimate list of smallest numbers and remove it from the original list. So this way, the first time this while loop is executed, we should get the list of 1 to 6. So I expect 1 to be returned and added to the smallest list and removed from the original list. Then we repeat with this list, 2 to 6. And we repeat this as long as we have less elements in this list than the count that this method receives as an argument. Now let's take a look at getSmallest method. So here, first we assume the first element in the list is the smallest number. Then we start iterating over the list, starting from index 1 up to a number of elements in this list. And for the current number, if it's greater than the minimum, we change the minimum. So if you're a bit experienced, you know that here we have a bug. But if you didn't catch it, that's perfectly fine. That's the purpose of this video. I'm going to teach you how to use debugging in Visual Studio to find bugs in your program. So how does debugging work? In terms of the process, first you need to put 1 or more breakpoints in your application and then run your application in the debug mode. When you run your application in the debug mode, the execution stops at your breakpoint. And there you can inspect the values of different variables to make sure they're holding the right value. And if not, you can change your code. So I'm going to put a breakpoint at the beginning of the main method here. You can put a breakpoint by pressing F9. Or you can remove it by pressing F9 again. And now we run the application in the debug mode. How do we do that? With F5. So remember this shortcut. F5 is run in the debug mode, whereas Control F5 is run without debug. So I'm going to press F5 now. So look, the program started and execution stopped at the line where I put a breakpoint. Now at this point, I can look at the values of different variables, or I can continue execution. There are a few different ways to continue execution. One common way is what we call step over. And the shortcut for that is F10. So if I press F10 now, this line is executed. So with F10, we execute one line at a time. Now I'm going to press F10 one more time and hover my mouse over smallest variable. Let's inspect this. So we have 654. So this is telling me that there is something wrong in this method, getSmallest. So let's go back. Look at this yellow arrow here. I'm going to drag this and put it back here. I press F10 to step over one more time. But this time, I'm going to step into this method because I want to know what is happening here. And to step into, we use F11. So remember the shortcut? F10 is step over, and F11 is step into. Now we press F10 again. So first, we define a new list. That's fine. F10 again. Now at the beginning of the while loop, F10 again and again. Now I can save my time by pressing another breakpoint here. So next time I run the application in the debug mode, I don't have to do all these F10, F10, F11. I can just jump here straight away. So F9 for another breakpoint. Now, to save my time, I don't want to jump into this method straight away because maybe this method is doing its job properly. So first, I'm going to step over it. So F10. Now let's take a look at min. So what is coming out of this method is number 6. And what was the input? A list with numbers 1 to 6. So this is telling me something is definitely wrong inside this method. So let's go back. And this time I'm going to step into it. F11. Now F10. Now I'm going to introduce you to a very useful tool when debugging your applications, the watch window. So you can open it via debug, Windows, watch 1. So what is this window? We can put the variables that are of interest to us in this window, and this way we can look at their values at all time. Then we don't have to hover our mouse over them one by one. It's much easier. Now, look at the code here. There are a few variables that are involved in this algorithm. One is min, another one is list of 0, and the last one is list of I. So I can put these variables in the watch window and look at their values at all time. So here in the watch window, min, list of 0, and list of I. Now note that list of I is not defined yet because I is defined in the for block, and currently we are outside the for block. So we step over this line with F10. Now look at the watch window. Note that the value of min is indicated as red. Red means the value just changed. So now min is 1. Let's continue execution by F10, 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 F10. Now look at the value of list of I in the watch window. So the current value in the list is 2. And we're comparing this with min. We are saying if list of I is greater than min, set min to list of I. So with this logic, we're constantly looking for a larger number. And this will return the maximum number in the list, not the minimum. So this is where the problem resides. Now I can easily fix this by changing this condition to less than. Now let's step over it, F10. So did you notice that this line was not executed? So the value of min was not changed. And as you see in the watch window, it's still 1. So it appears the problem is solved. Now I can continue stepping over different lines here, but I think we'll kind of get lost in the detail. Let's step out of this method and quickly look at the end result. How do we step out? With Shift and F11. So let's repeat the shortcuts. F10 to step over a line, F11 to step into it, and Shift and F11 to step out of a method. So now I press Shift and F11. Look, we are back in getSmallest method. Now I can step over this line and look at the value of min. So F10. I think the problem is solved. Look at the list. So our list is numbers 1 to 6, and min is 1. So let's stop the debugger and run the application in the normal mode without debugging and see if we get the right result on the console. How do we stop debugger? With Shift and F5. Again, to review, F5 to run the application in debug mode, and Shift and F5 to stop the debug mode. And now I'm going to run the application without debugging with Control and F5. Awesome, we fixed the bug. But wait a second here, we're not done yet. This program has a few more bugs that you haven't seen yet. And that's what we're going to cover over the next few lectures. So we're going to review these debugging techniques, and along the way, I will also show you other tools to fix the remaining bugs in this program. One thing that distinguishes a good programmer from an average one is that a good programmer often thinks of edge cases. What I mean by an edge case is uncommon scenarios. An average programmer often assumes the end user enters values into the forms the way the programmer expects, but the reality is different. So back in the example from the last lecture, look at the first line here. We have a list of 6 numbers. And in the second line, we want to get the 3 smallest numbers in this list. What if we only have 2 numbers in our list? So I'm going to remove these 4 numbers and run the application. The application blew up. We got an exception. So close the program. We got argument out of range exception. Index was out of range. So what's going on here? When you face situations like this, that's when you start debugging. So I'm going to run the application in the debug mode and find where in the code we're getting this exception, what line. So remember our shortcut, F5 to run the application in the debug mode, Control F5 to run the application without debug mode. So I press F5 now. Okay, we stopped at this breakpoint. I want to continue execution. So in the last lecture, you learned about step over, step into, and step out. There is one more way to continue execution, and that is continue till the next breakpoint. So I can press F5 again, and look, now we are at our second breakpoint. So far, everything seems to be fine. We didn't get an exception. So let's continue. F5 one more time. Okay, we're back on this line again. One more time. Doesn't seem to be right. You know what? I want to get rid of all these breakpoints and just run the application and see where exactly it blows up. So this is something that often comes up when you're building big applications. You put various breakpoints here and there, and once you fix the bugs, you forget to remove them. And then these breakpoints get in the way. So how do we find them and how do we remove them? We go to debug. One way is to go straight here and click delete all breakpoints or disable all breakpoints. That's the quick way. There's also another way. You can go to Windows and breakpoints. So here you see all the breakpoints in your application. What file, what line, what character. You can double click, go there. You can disable them or enable them, or you can delete them. So I'm going to delete both of these. Now I want to restart the application. The shortcut is Control, Shift, and F5. If you ever forget these shortcuts, you can always find them. Just go to the debug menu here. So look, we've got continue, which is F5, stop debugging, which is Shift and F5. And now I'm looking for restart, which is Control, Shift, and F5. So I restart the application. Okay, this is where it blew up. So I put a breakpoint here as my starting point. F9. Now let's look at the exception, argument out of range. So what's happening? Let's close this. Look at this list. This list is empty. There are no elements here. Yet we're assuming min is the first element in the list. So this code is not really reliable. And this is one of those areas that separates an average programmer from a good programmer. Now, before we fix this bug, let's see why is this list empty. If you remember this line, the purpose of this was to remove the smallest number from the list. And we continue repeating this until we get enough small numbers based on the value of count here. So as we are removing these numbers from the list, at some point, the list becomes empty. In this case, because our list originally had 2 numbers in it, after 2 iterations, the list became empty. And that's why we get this exception. Now, the question is, how do we fix this bug? We have a few different ways here. One way is to have an if block in the getSmallest method that checks if the count that we pass here is greater than the number of elements in the list. The reason we're getting this exception is, in this case, we want 3 small numbers, but the list is only 2. So this is one way to solve this problem. Another way is to put a conditional in getSmallest method. So we need to check that if the list is empty. So if the list is empty, what should we do? Should we return 0? I don't think so. Imagine if our original list, this list here, had a number of negative numbers. Then at some point, we get here, the list is empty and we return 0. So the program ends up displaying 0 as one of the smallest numbers in the list, which did not exist in the list in the first place. Another option is to check if the list is empty here, throw an exception. So that's one of the conditions or criteria for this method to do its job. This is what we call defensive programming. So when we get input here, before doing any processing, we want to make sure that the input satisfies some criteria. If not, we're not going to continue processing. Now, there is a third way here. Can you see that? It's not quite obvious, but yet it's very important. Look at this method, getSmallest. This method has a side effect. So, this original list that we sent here, we're continuously removing some numbers from it in order to calculate the smallest numbers. And side effects are not good. They make your methods unreliable. And they're often hard to find bugs that are because of side effects. Now, for a second, I want to stop the debugger here. I'm going to put those 4 numbers back here. So if you run the application now, everything works. Okay, we got 1, 2, 3. But let's iterate over the original list. So I'm going to change this to numbers. Look at the result. Our original list is changed. 1, 2, 3 is removed there. And this is what I meant by side effect. So, in my opinion, that's a more serious problem that we need to address first. Now, that may or may not solve the bug that I introduced at the beginning of this lecture. That's fine. If it doesn't fix it, we're going to continue debugging and find the right way to fix that bug. So the first thing I want to do here is to remove the side effect. How do we do that? So in the getSmallest method, instead of removing these numbers from the original list, I want to create a copy of this list to do my processing. So I call this list buffer. So we create a new list and pass that original list here. And then instead of removing these numbers from the original list, I remove them from the buffer. And one more change here. We need to change this list to buffer. So now look, this list, the original list, is only used during the creation of the buffer. Now let's run the application. Okay, beautiful. The original list is not affected. So we removed the side effect. Now let's get back to the original bug that I introduced at the beginning of this lecture. So I'm going to remove these 4 numbers and change the for each block to look at the smallest numbers. Let's run the application. Okay, we still have a problem here. So in the next lecture, I'm going to show you how to fix this problem. Okay, back here, we want to fix the bug from the last lecture. So we have a list of 2 numbers and we want to get 3 smallest numbers in this list. And as you remember from the debugging session in the last lecture, this problem happened in this line here. So at some point, the input list that we give to this method becomes empty, and we try to find the minimum number in an empty list. Now, we have two choices to fix this problem. We can put a conditional statement here and make sure the list is not empty. That's one way. The other way is to have a conditional statement in this method here. So we want to make sure the count that we get here is not greater than the number of elements in this list. Now, both these solutions might sound reasonable, but which one do you think is a better solution? I think a better solution at this point is to check if count is not greater than the number of elements in this list. Why? Because we're asking a question in this method, but the question itself has a problem. If the question is meaningless, we cannot get an answer. Let me use a metaphor. Imagine you ask your friend, do you eat with a pen and paper? Doesn't make sense. The question should be, do you eat with a spoon and fork or with chopsticks? So when the question is meaningless, we cannot provide an answer. So in this case, I'm going to attack this problem by making sure this method gets smallest, gets the right arguments as the question. Now, so I'm checking if count is greater than the number of elements in this list, then we throw an exception of type argument out of range exception. This is a useful technique in defensive programming. So we check the input first before doing any processing. Now, one more thing I would like to add here. We can add a message here. Count cannot be greater than the number of elements in the list. Let's run the application now. The application crashed again. So have we solved the problem? Yes, we did solve a part of the problem. Now you might ask, Mosh, how is this better than before? Because before we got an exception anyway. Let's see the difference. Read the exception. Argument out of range exception. Count cannot be greater than the number of elements in the list. So this exception is more meaningful. It's telling me why the program crashed. So when it comes to troubleshooting, I would have a better idea of what's happening here. I would know that the client of this method, in this case, this line here, is sending the wrong data. Let me temporarily comment out these two lines here. And run the application again. Read the error now. Index was out of range, must be non-negative and less than the size of the collection. This error message is too low level and is coming up from a method further down in the list of method calls. So it came from this method here. The important thing to consider here is we should not get here in the first place. The program should stop execution at this point, and that's why we added this if block here. The reason I add this here is not just to display a more meaningful message. It's to prevent your application from going in the wrong state. Now, this is a very simple program, but imagine if this was a big real-world application with a database. If your application goes in the wrong state, there is a chance that sometimes that state gets persisted in the database. And then next time you load a page, you show some data to the user that makes no sense. And in situations like that, you're going to have a hard day finding that bug. You're going to spend a day or two, maybe even a week, to figure out what was happening. Okay, back to the business here. Now we solved this problem with this count being greater than the number of elements in the list. What if count is 0? Do you think it's a valid question? Give me 0 smallest numbers. No, it's a ridiculous question. What if it was -1? It just doesn't make sense. So we need to change this slightly to something like So if count is greater than the number of elements in the list, or smaller than or equal to 0, that's out of range. Of course, we need to change this message slightly. Count should be between 1 and the number of elements in the list. Let's run the application. Okay, we got this meaningful exception here because we passed -1 to this method. Now, to further expand this topic of defensive programming, what if we send an empty list here? Something like this. You might say, okay, Mosh, we can do another check here to make sure that the list is not empty. We can certainly do that, but in this case, I can show you that the existing logic would work for an empty list. Why? Because first of all, I know we cannot send -1 or 0 here, so we need to send 1. And because 1 is greater than the number of elements in the list, this logic will stop the program execution. So there is no need to write if list.count is 0, throw an exception. It's just redundant. But what if the list was null? What if I send null here? Then I'm going to get another low-level exception further down the track. So let's investigate that. Run the application. The famous null reference exception. Object reference not set to an instance of an object. So this is something that I would like to prevent at the beginning of this method to make sure the question is the right question. So if list is null, we throw an argument null exception. Okay, so in this lecture, we covered some of the edge cases around this algorithm, and we improved the reliability of our code. And that brings us to the end of this lecture. Over the next couple of lectures, I'm going to show you more debugging tools in Visual Studio. I hope you enjoyed this lecture, and thank you for watching. Okay, back here, I changed the declaration of our list back to what it used to be. So numbers 1 to 6, and also added number 3 here, so we get 3 smallest numbers in this list. Note that we have one breakpoint here. Now I'm going to run the application in the debug mode. So F5. So we are here. Now this is a very simple application with only 3 methods. But often a real-world application consists of tens, hundreds, or even thousands of classes with a few methods. So sometimes when you're debugging, you may get lost. Now I'm going to introduce you to a window that shows you how you got here. This window is called call stack. So you can find it in Debug, Windows, Call Stack. So this window shows the order of methods that were called from the moment that the application ran up to where you are now. The item on top of this list is your current location, and the item on the bottom of this list is where you started. So we can double click here. That brings me here. Let me dock this window. I double click this one. So before we jumped into this method, this is where we were. Now I double click main, and this is how we started. So we went to this method and then ended up here, and finally in get smallest method. So if you get lost, remember the call stack window. And one more thing. So earlier I told you about the watch window. So you can bring it from debug, Windows, watch 1. Now watch window is useful, but sometimes it may get a bit tedious to type the name of variables you would like to inspect. So I'm going to show you 2 more windows that are useful in debugging. Autos and locals. You can find both of them under Debug, Windows, Autos, and locals. So let me bring it up here. So the autos window is like a watch, but with automatic list of variables. Visual Studio, based on where you are in the code, detects the variables that you could be interested in. So here you see it has list.i, which is the loop's counter variable. We have the list variable, which is the input into this method. List.count, because we have referenced it here in the code. List of I, because we're using it here. And min, again, we have referenced that here. So this saves you time. The locals window is similar to the autos window. So the difference is it does not list all kind of variations that you see in the autos window. For example, here we have only list, I, and min. Whereas in autos, we also had list.count and list of I. So the locals window shows the variables in the local scope. So depending on your preferences, you might use locals, autos, or the watch window. I hope you enjoyed this lecture and thank you for watching.
In this section, you learned about debugging tools in Visual Studio. So here's the process. You put one or more breakpoints in your code and then run the application in debug mode. Next, you continue execution and inspect values of different variables using the watches window. Remember your shortcuts. F5 to run the application in debug mode, F10 to step over a line, F11 to step into a method, Shift and F11 to step out of it, and Shift and F5 to stop the debugger. I hope you enjoyed this section and thank you for watching. So you made it this far and I hope you have enjoyed this course. Now this course is the first part of my 3-part C# course. Over the next part, which is called C# Intermediate, we'll take a closer look at C# classes. I'm also going to talk about a very important topic that a lot of C# developers struggle with, and that is called interfaces. I'm also going to introduce you to object-oriented programming. I'm going to talk about encapsulation, inheritance, and polymorphism. So I hope to see you in the next course, and remember, you can find coupons to my other courses at the end of this course. So have a great day, and I hope to see you soon.
So, you've made it this far, and I'm really proud of you and your enthusiasm for learning new things. I hope you've enjoyed this course and learned something new to apply in the real world. If you've been happy with this course, could you please take a minute and leave a review for my course? I love to hear about your experience and how I could help you. This is the most rewarding part of this journey for me. Remember, reading your reviews put a smile on my face during the day and keeps me motivated to create more quality content for you and other developers. So if you have been happy, I would really appreciate if you take a minute and leave a review for my course. And if you like to criticize, feel free to send me an email. I welcome all criticism because this way I can learn something new and become a better instructor. My email is programmingwithmosh@gmail.com. I'm looking forward to hearing back from you and wish you the best in all stages of your career and your life. Have a great day.